Okay. Well, welcome to the hang on. December 16th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been working on my distributed K9Q radio system, learning a few new things and being confused by others. So making progress, but that's how you figure things out. So that's it for me. Next on the list is Dave, which I assume is Dave Witten. Go ahead, Dave.
I'll gotta get my goggles on. Um, Not a lot of excitement from this end um, uh, this week. I've been doing some personal things and just a little bit with Nathaniel's student, who's uh, who's starting to work on the magnetometer code dashboard thing. So, but other than that, not much. Back to you.
Oh, okay. Next on the list is what is this? It says iPad 2.
Oh, pardon me. I'm Bob W1 X-ray Papa.
Okay.
I usually use a computer, but I didn't realize that it didn't have my call and name on it. But
Well, what have you been up to?
I was a little disappointed in the meteor scatter.
Uh,
It was so it was it was not much meteor scatter and 99% sporadic E or F layer propagation here at I'm in coastal North Carolina, just north of Wilmington in a small community. Second location. And I was quite disappointed because it was you couldn't hear any meteors for all that was my experience anyway. I don't know if I hope people had a better experience than I did. Anyway, that's kind of where I am.
okay. Well, next on the list we have Clint, K7OEI. Go ahead, Clint.
I've been doing mostly stuff to the shack, not in the shack. Um, uh, Things got let go on a big project I had, and I have at least a few places where the floor is clear enough that I can walk from one side of the room to the other without making very large steps. And considering I'm 2 meters tall, that could be pretty large steps indeed. So anyway, uh, hopefully get back to a few other actual fun radio projects soon, but just still whatever. You got to be able to see the workbench before you do work on the workbench.
Right. Well, very good. Glad that you're bringing up. Next on the list is Dave H. W6OQ. Go ahead, Dave.
Okay, good evening, everyone from Los Angeles. Um, yeah, they're working on my house here and was quite noisy today. Didn't get nothing done. Um, anyway, that's about it. Just here to see what I can learn.
Very good. Next on the list is David McGaw. Go ahead, David.
Good evening, everyone. Well, primary mission these days is feeding the wood stove. It's quite cold here. Um, and but I guess it's supposed to get into the 40s toward the end of the week and then cold again. But working on our ground station a bit, debugging some stuff with USRPs that have failed. Luckily, they give schematics, but the components are out of date, so I'm having to cross various components like an amplifier, mimic amplifier that died. Oh, and by the way, Clint, thank you for your letter with some components. And yeah, oh well, our big news here, of course, is that my PI, my boss at Dartmouth, snagged a very nice NASA mission. It's a 9 spacecraft that will be orbiting similar to what our CubeSat is doing now, but much larger spacecraft and much greater numbers of them. And it will be imaging the Earth's geotail using the particles that get scattered back. And $180 million mission spread between a number of institutions. But I was concerned. I know she does very good presentations, and but being a woman, that's one of those no-no terms. But they must have kind of ignored that. I guess Robin can be a man's name. But
Yeah.
anyway, we got the mission, and that's exciting. I'm supposed to be working on some also some uh, citizen science in connection with that, and we haven't quite heard about that side of it, but hoping that that will eventually dovetail into what we do here as well. So back to net.
Very good. And next on the list is um, Jay Schwartz, WB8 SBI. Go ahead, Jay.
Hmm. Well, good evening, everybody. Not a whole heck of a lot here. Uh, Actually, nothing amateur radio wise of any import. So I'll just say happy holidays to all and stay warm, everybody. Take care. 7-3. Catch you later on down the log. Back to net control.
Yes. Uh, Next on the list, we have Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. Nathaniel is currently at AGU. That's where he is now. And I was wondering if he was going to join from his hotel room, but looks like he's still having fun after the festivities. But anyway, I provided some slides to Nathaniel for his MacGyver session at AGU, which is a bunch of presentations and discussion during that session. It was really well. It seemed really well organized, and hopefully, it's a very very fruitful. But I couldn't be there. But anyway, I've been working. I just received run 3 of the preamp board. There was a silkscreen error on run 2, so I ordered another preamp board for my BLF active antenna, and I just got the board and the components today. So that means that I'm gonna start assembling, and then that's going to be the board that I'm going to be testing at Nathaniel's house when I finally install the system next month. I've been trying to get it done this month, but it doesn't look like it. There was the interface board. The DC jack is over to one side a couple millimeters too much, so it might bump into one of the screws of the case. But I missed that. But it also might fit. I'm waiting for that board to come to see if it'll fit. But I might have to do another run of that. And lastly, the one of the most exciting things is that the VLF, Nathaniel's VLF, or the system at Nathaniel's house is now back online and streaming, which means that anybody could actually listen to the stream. And the reason why people listen to streams of VLF receivers is it's the same thing as you going out in the wilderness, in the areas where there's not a lot of power lines, and you listen for whistlers and dawn chorus and things like that. But this way, with modern technology and with software, you could listen to the stream. That also comes with filtering. The website is dk7fc.info, and the Springbrook stream is online along with a bunch of others. And the good thing about that is that it uses PHP and it interacts with VLF-RX tools to provide an Ogvorvis stream that can be played with VLC and in Firefox. Doesn't seem to play in Chrome. Lastly, and one more quick note, I started to work on the documentation for the system. So I wrote up the introductory parts, or at least part of the introductory, because I was given access to it. So I started on that. That's all I have. Back to the net.
You're muted, Dave.
Sorry about that. I got knocked off for a minute and jumped back on. So, next on the list is Michael Howen, AC0G. Go ahead.
Good evening, everybody. I've been continuing to work on some software to excise the grape uploads from under Whisper Daemon and have them in effect stand alone. And I've also been working on some what promises to be some interesting time standard measurements, taking advantage of the GPSDO we're using, and even without having an injected PPS, which will definitely make things more accurate altogether, using the incident, the payload that's inside the various receivers we're listening to for WWV and WWVH and CHU to develop a pretty remarkably accurate approximation of UTC time, and consequently able to give us some interesting information about propagation, total electron count, time of arrival, that kind of thing. So I'm kind of tantalized by it. I want to make sure it's sound, or so that's among the things I'm working on. I'm hopeful too that once that's done, it can provide a basis for accurate Whisper Daemon, grape, super darn, codar, FTP 4 and 8, those kinds of things. PSK reporter uploads from a timing perspective, whether or not anybody has a PPS injection to increase the time accuracy. That's enough. Back to Nat.
Very good. And next on the list is Phil Karn, K9Q. Go ahead, Phil. Muted.
Yeah, just having to find the window with the little button. Okay, hi guys. Yeah, I've been into my usual winter mode where I become even more disconnected from the clock and just start hacking for, all night long. Anyway, lately I've been revamping the spectrum code some more, and I've got it working pretty well. I've added support for different sampling windows, and you can really see the difference on K9Q Web, especially when you zoom in on carriers of really strong AM broadcast stations. Anyway, that's what I've been doing lately. probably think of something else later, but that's all I can think of right now.
Very good. Next on the list is Scott Newell, N5TNL. Go ahead.
Hey guys, lots of work and family stuff recently, but I did upgrade a few terabytes of cloud storage to ZFS. I repaired my Pi time server, studied the front end of the Whisper decoder, and did some hacking on Clint's clicky signal at the northern Utah side. So a little bit of progress, quite a bit of confusion, and that's it for me.
Okay. And next on the list is Tom, N5EG. Go ahead, Tom.
Okay, good evening, Dave. It's been an interesting week. I got final confirmation from Infineon that the approach I'm using on the quad receiver will not work. And an interesting design choice. If you get a parity error on the control channel, it just kind of decides to stop working. You have to lose samples, and so it's not going to work. So I have forked, that's spelled with an O, forked the circuit board to a new version where I'm going to insert a Xilinx FPGA in between the ADC chip and the Infineon FX10. And it's sort of a good news, bad news situation. The good news is I had done a lot of work on a predecessor FPGA, and I can reuse quite a bit of that. The bad news is the LVDS interface is not native on the Xilinx part that I've got. But the good news is I found a intellectual property. It's free open license. Well, I had to license it, but it's free for LVDS receiver, and it's been tested with the exact ADC chip that we're using on the design. The bad news is it's written in VHDL, not Verilog. The good news is I found a VHDL to Verilog translator on GitHub, and the bad news is it won't translate it because of it says in it Xilinx VHDL it's got problems with and doesn't work. But digging into the Xilinx part, it turns out that you can mix and match VHDL and Verilog submodules inside Xilinx Vivado. As long as the submodule is synthesizable, Vivado, according to this app note, is capable of plugging VHDL modules and Verilog modules together. So this Xilinx module will run up to about 600 megahertz clock rate on the Kintex 7. We're using the Artex 7, which is a slower part, but the fastest we'll run it at is a 500 megahertz clock rate. So there's a little bit of light until we go out and find the next tunnel. Back to the group.
Well, I guess. I don't know if you can still hear me, but I'm locked in.
We do hear you.
Oh, good. Well, I'm locked, but I guess that's the end of the list. So we're open for general discussion, and I'll try to reboot and get back on.
Don't everybody talk at once.
So, Tom, I didn't really hear what exact, I couldn't hear the bit about what Xilinx chip you were targeting.
I'm targeting one of the Artex 7 FPGAs, ARTIX.
Uh-huh.
They're 28 nanometer, about, I don't know how many years old, but they're pretty fast. I cannot run LVDS out at the speed of the ADC. The FPGA is just not fast enough. But what it can do is receive LVDS and then translate it to parallel low voltage CMOS and run that into the FX10. That gets rid of a lot of the LVDS state machine problems that we're currently trying to solve on the FX10. So that's encouraging. The solution involves running a 500 megahertz DDR clock from the ADC over to the FPGA. And so it captures the data line on the rising edge of the 500 megahertz clock and the next bit on the falling edge of the clock. And it's got a special IO module that's right in the IO pad of the FPGA that can be clocked at 600 megahertz on the Kintex. The Artex, I think it'll run at about 500 megahertz. It's about 20% slower, so it should work. And that should allow us to clock in the LVDS data into the FPGA and then reformat it as LVDS. The good news about having an FPGA, we can go ahead and mark PPS right in the data stream. We can mark channel alignment right in the data stream. So it brings back all of those nice things that we lost when we got rid of the FPGA, but of course it adds cost and complexity. So it's interesting. Fortunately, I had documented the old FPGA. When I stopped, I still have the archive file of it. So I've got a fair amount of stuff in there done already. And the circuit board I've archived and I'm forking a new design there. So by the time the GPIF3 software gets out at Infineon, maybe I'll have the rest of the project caught back up again. So if that's the case, then we won't really lose any schedule here.
Well, it's been a long journey.
Yeah, I'll be starting on version 3. At least I haven't spent any money on prototypes.
It's remarkable that you've kept your balance with all that good news, bad news. I mean, that's quite the buffeting back and forth.
Yeah, I set up a virtual machine today so I could load all of the VHDL2 Verilog translator tools and support libraries. For old software timers on the list, it uses Lex, Yak, and Bison to do the translation from VHDL to Verilog. And if you've been in the business as long as I have, those packages go way back.
Compilers, right?
Yeah, those are like late 1970s tools.
Right. Yeah. They go way back.
And the news is they still don't work.
Or they work just as bad as they always did, right?
Yeah. The notes on this tool that I downloaded from GitHub said that the Xilinx VHDL caused it some problems. And I can verify that that's a true statement. So, but it was nothing ventured, nothing gained. I thought Phil Karn would wake up when he heard Bison.
I don't think I ever used it. I know the name, but I never used it.
Yeah, it repackaged Lex and Yak into a little bit newer package.
I was never a compiler guy, so I didn't get into that stuff.
Yeah,
I went the operating system route when I was in school.
Yeah, I remember folks working on one of the initial C compilers, and they wrote the really crude, limited first one in PDP-11 assembly, and they got it working well enough that they could run Yak C code in it, which then created the next version of the compiler. And then they fed a more comprehensive version of C into that and let the C compiler
it's called
compile that, and they
bootstrapping in the compiler world.
themselves up.
Yeah, right. That's what it's called, bootstrapping in the compiler world. If you lose all the software, you have a source of the compiler, you won't be able to compile it. Where are you going to get the binary for the compiler to recompile the C compiler?
Yeah, it was crazy.
Powers have gotten pretty good, you know. I mean, lint, remember lint? We used to use lint all the time, but now, I mean, the stuff built into the compiler is more powerful than lint ever was.
Really?
And then sometimes I can throw a source file at ChatGPT, it'll find the bug right away. It's pretty good
I
at
was
static analysis, especially corner cases, you know, obscure corner cases and stuff. It seems to be pretty good at finding those, or, you know, forgetting to clear a pointer, you know, that kind of stuff. Things you look
Yeah.
at multiple times and don't see. Anybody want to see what K and IQ Web looks like right now with new Spectrum code under it?
Sure.
Yeah, yes.
Okay, hang on a second here. The right window. Here we go. Share. Okay. Yeah, this is my my loop antenna on the HF at the moment. I'm looking at some persistent, annoying stuff here in the middle that's been there for years. Obviously, some kind of switcher, but I don't know what it is. This actually shows up a lot more clearly than it did a few days ago because the big problem with generating these displays is the trade-off between display quality and CPU. And the original Spectrum code used a lot of CPU in doing wide scans like this one. I've come up with, I think, a better approach. The original approach for Spectre was just to look at the FFT bins that are used that are made in the convolver. The problem with those for displaying frequency spectrum is they're not windowed. They're implicitly rectangular window, which means they have very high side lobes and go out a long ways. And that was very obvious in the display. If you look like along the strong AM broadcast station, you'd see, you know, a haze that was spread out on either side over the rest of the band. So what I've done is I've re-implemented from scratch the whole Spectrum subsystem so that it has two modes. In the narrowband mode, it does what it was doing before. It sets up a channel of the right sample rate and then puts an FFT on the output of that channel with a window and does all the right things. So that works actually quite well at for narrow resolution bandwidths and narrow spans. For wide spans, though, do something completely different. I sample the raw input A to D stream. I just peek at it before it goes into the convolver, right as it comes out of the A to D onto a ring buffer. And whenever the user asks for a spectrum, I peek at a window of that, a piece of that, run a bunch of FFTs, and then generate the result on the fly. So if you don't poll for it, it doesn't cost anything in CPU, which I kind of like. You know, if a web user goes away, even if the session lasts, it won't consume any CPU time. The problem with that is that the noise floor got very noisy. It was very spiky, and the previous one had a nice smooth noise floor, kind of like this, but it cost a lot in the CPU, especially when you zoomed all the way out, which is what a lot of people were doing just to look for, you know, overall performance and source of noise, like I know Rob was. So what I've done is I've done a compromise. The way you get the noise floor smoothed out is by averaging. You got to take more input points than you're producing output points. You have to average them in the process. So what I do is I take a series of back-to-back windows out of the input A to D buffer, and then run FFTs on each of those, and then average the results. And that's what you get here. So I do a trade-off with CPU by giving each operation a budget for the number of points that it can examine. It can either examine it with a relatively few large FFTs or a whole bunch of smaller ones that are averaged, which you do for a large resolution bandwidth. And that's actually working out pretty well. The FFTs theoretically end log n in performance, so the large FFTs ought to be more expensive, but in practice, that's swamped by cache hit ratios and memory access patterns and stuff like that. So it's pretty much constant all the way through the whole zoom range. And on my B-Link AMD machine, this is consuming maybe about 8 to 10% of one core, which I consider acceptable. But I can make this a tuning tweak if anybody, you know, wants more. I've already gotten a complaint from Australia from Mark Jessup that this is still too much to run on a Pi 4 when looking for radio signs. So I'm probably going to have to give him the old code back as an option. But it was really ugly, and I wanted to get rid of it, use common code for everybody, but it doesn't look like that's going to be possible. But hey, that's real life software engineering. So if anybody can tell me what this crap is around 6 megahertz and 49-meter broadcast band, I'd sure like to know. This kind of stuff is very characteristic of like switching power supplies and battery chargers that pulse up and down in power levels. And I assume it's just whatever is radiating is resonant in this range. It's obviously got a much lower fundamental frequency.
Yeah. Do you have any dimmable LED lights?
No, there will be lights. I've already been trying to turn off all our own lights, and they all seem to be pretty quiet. We've gone to the newer LEDs that I think are just a long series string with a capacitor as a ballast. And those seem like they ought to be, inherently clean. If somebody has any other observations, let me know.
Yeah, I've
Let me
seen.
show you what the effect of Windows is down here in the AM broadcast band. Here's the good old AM broadcast band. Let me renormalize. Oops, I got to put a tuner in here for that to work. Okay, now this guy right down here is XEMM, I think it is 690. It's a border blaster in Tijuana, not far away from here. And it's the strongest signal I see across the entire spectrum, even through Paul's Schelling filter. So this is the one I used for really stress testing Windows. If I zoom in on this guy, renormalize, zoom some more. I added a much more zoom steps. I think that's something we still have to figure out would be good here. Let me retune. Switch to A. It doesn't really matter what mode I'm in. But if you zoom really close in, I mean really in, you can actually see the gap between the carrier and the modulation because of the high pass filter in the modulator. And that's a really good stress test for Windows. Right now, I'm using a Kaiser window with a beta parameter about 7, which is very low side lobes and a relatively wide main lobe. Now, I don't have the controls in KNIQ Web to tweak this, but I do have them in my control program. So I'll bring that up and yeah, here we go. Okay, I'm going to first show you what happens when I go to a rectangular window. I think I did. There we go. Nope, didn't take. It's a bit of a kludge here. There we go. See the difference? That's a rectangular sampling window. You can see how that gap around the carrier is now filled in with side lobes. It's huge. However, the main peak got a lot narrower. So this is that fundamental trade-off. So I went overboard last night. I implemented support for a whole bunch of sampling windows, Hamming, Han, Gaussian, Kaiser. Well, I already had Kaiser, rectangular, and so forth, just so I can get a better intuitive feel for what these things do. And anybody else, of course, is welcome to play with this too. Anyway, this is deep into the mathematics that I've been playing with for the last couple of weeks. Because once I gets into something like this, I become a purist and I just want it to like really, really work so I never have to come back to it again. Anybody else playing with this stuff? I know people are using KNIQ Web, but anybody doing anything this detailed?
Bill, is this a separate display program from someone else, or is this now bundled into KA9Q?
This is just KNIQ Web.
Okay.
It's a standard. It's the current snapshot of KNIQ Web on WA2N's GitHub page.
Okay.
Um, I would like to change it. Actually, I have made some tweaks here. I added more zoom levels. Hey, anybody who's familiar with using Spectrum Analyzer or uses it more often than I do, if you can comment and get some ideas on what the zoom levels ought to be, that would be helpful. The problem is you kind of want both powers of 10 and powers of 2 or factors, and unfortunately, log base 2 of 10 is not an integer, so that makes for some uneven steps.
This
Anyway,
requires recompiling K9Q Web, right?
yeah. The Zoom table is in both the C program on the server side and in the JavaScript. It gets sent down to the client. The two tables have to match. It's kind of nice that they exchange it, but I didn't write it, and I trying to minimize my changes to their code because I know it's still under development. So I don't think there's any DRM coming in this early in the evening. There is late at night, but it's almost hypnotic to watch a DRM waterfall. It's kind of like watching a lava lamp, especially if you listen to it. It's a good way to lull yourself to sleep. If anybody's ever done that. Too bad there's so little DRM on the air. Be kind of fun to play with more often. Once in a while, I can decode signals from China, but it's kind of rare. I can see them all the time, but they're usually too weak to decode. Even at KFS, they're usually too weak to decode. So let's see, how far can I go down here?
I got an email from Gwyn this morning describing how a friend of his named Nigel and he had installed a 888 receiving setup and were listening to the BPM broadcasts from China, transpolar propagation on. They broadcast on 2.5, 5, 10, and 15, just like
I often hear them.
WWDH does.
I often hear them. Their CWID stands out.
Yeah.
So yeah, of course I look at WWV all the time. It's a wonderful test signal. I'd hate to see it go. Oh, this reminds me of something else. Over the weekend, I noticed that there was a 10-meter contest going on. I mean, I've never seen a 10-meter. I mean, it looked like CB almost in terms of the activity level. I mean, it was just saturated, especially in the CW portion. So then all of a sudden, my display here just goes orange, and it turns out it's K6AM. He's about a kilometer away. I think I've seen him a few times at local club meetings. I have no idea how much power he's running, but I can certainly guess. So anyway, yesterday that sent me on a project to use his signal to try to improve my AGC algorithms. And I think I've succeeded. The problem is that when a signal is extremely strong, sometimes you get a crunch at the beginning. The gain is not reduced quickly enough. So I now have a two-stage gain. I have something that will detect these really strong peaks and respond more rapidly than the usual standard AGC would. And I also have the other problem of when the signal goes away, I have a lot of gain to recover, and you can hear silence for too long, especially in a contest situation. Oh, they just changed their program. You see the audio on too. So I think it's working better now, but everybody seems to have really strong opinions on how an agency ought to operate. So if anybody does have any opinions on this stuff, because remember, I'm not a DXer or a contester, let me know. I'd be happy to put them in here so you can play with them. Anyway, it's about all I can think of right now. So you just want to watch the pretty dancing peaks here.
You talking about the front end AGC or talking about
No, the channel AGC.
Okay.
Especially single sideband and CW. I was just having an interesting conversation with ChatGPT through all this. Is this making suggestions? It suggested the idea of looking for a rapid peak sooner than a frame time by dividing it up into pieces and then looking to see if any of those are higher than some threshold, but not to divide them into too many pieces, because if you don't use enough samples in each of your averages, these statistical fluctuations will be too great. You get a lot of falsing, which was absolutely true. So I'm finding it actually a surprisingly useful tool for this kind of stuff. It actually seems to, it makes mistakes. I've seen it confuse time and frequency domain more than once. But if you correct it, it will get on the right track. And not every idea it has is a great one, but it often gets you thinking in the right direction. I haven't tried any of the other AI agents. Anybody really have a strong preference for something other than ChatGPT for programming? I hear Claude mentioned a lot, or Copilot.
The experience I've had has been in some. I haven't had enough, I guess, to be able to form strong opinion. The ones that do really well, there's a Sonnet version. I guess it's is it Claude?
Yeah.
Sonnet 4.5.
Is it designed for programmers?
It's quite good for programming.
Yeah. I usually don't have it right code. That usually turns out to be, well, in the past anyway, it's turned out to be a waste of time. I mean, it's giving me C code that just on inspection, you can tell it's not going to work because it's walking past the end of an array, that kind of stuff. And you try to correct it and then fixes that because something else wrong. So I generally don't do that. I generally have it explain the math or just point me in directions that I can go explore. And that seems to be what it's most useful for. This obviously is WWV on 5 MHz. You get an interesting bouncing effect with these sidebands because of the one per second modulation. Down here, I use overlapping windows to try to smooth out a lot of that variation. For the larger resolution bandwidths, I use windows, but I don't overlap the windows. They just follow each other consecutively. However much I want to spend on making that particular spectrum. So yeah, before I'm done, I'll have this turned into like an old HP instrument or something. I mean, it's just math, right? I mean, it's just code now, right? I mean, we used to take really precision RF engineering. You can now just do with, C code. Once you've got the samples, that is. That's the hard part. That's what you guys are working on. I wonder what that is. That peak right above 5. I mean, I'm using 1 Hz bins here, so. It could be ionospheric Doppler on somebody else. I don't even know whether this is WWV or WWVH. Probably WWV.
Probably with it being that powerful, but that is interesting. Just right above it, you see, right? That little
just a higher frequency.
Smudge above the carrier.
Yeah. I mean, there's plenty of modulation on everything else. See, WWV is in the silent period right now, so I think what I'm seeing there at ±6 is WWVH's tones, 600 Hz tones, and WWV is not sending tones at the moment.
I'm noticing sidebands 5 kilohertz apart, and they're going to in unison.
What do you mean?
There's, if you look 5 kilohertz, well, no, now it's 6 kilohertz.
6 kilohertz?
No, 600 hertz. Oh, I see. I'm looking at the scale room.
No, each vertical bar here is 100 Hertz. So what you're seeing there is the carrier and then the 100 Hertz subcarrier around it.
Right.
It's pulsing on and off. That was interesting. That was 300 Hertz. No, it generates 300 Hertz other than, well, it was a voice announcement. This is zoomed way in. I'm only looking, the whole span here is plus or minus.
By the way, propagation is crap right now. I can only hear 10 megahertz and below. I can't hear 15 right now.
Well, K index is only 1.
Yeah.
That's a nice little feature that the web guys put in. And down the corner, they fetch the current boulder prediction. So, and it's just right there. It's really nice. You don't have to go looking for it. Solar flux 118 A6 K 1.00 as of 0010 UTC today. So it's about 2 hours old, 3 hours old, something like that. I don't think the update to 3 hours.
I don't know.
So let's zoom out a little bit here. Things will be a little bit faster so I can see the modulation sidebands. There we go. And rescale. Obviously, things are a little faster now because the time it takes to generate one spectrum is going to be at a bare minimum 1 over the inverse of the resolution bandwidth, which right now is 4 kilohertz. So it samples a very small piece of time. The problem is that throws away a lot of energy, so you lose the opportunity to do averaging or to catch very short-lived signals. So, like I said, now I have a budget for each of these transforms. I give it a budget and a number of points that it can process, so it will process a relatively fixed amount time. It's not 100% because that's not practical, but it grabs a certain fraction of the or a certain span of time from the input to make one averaged spectrogram.
What you're seeing in there, though, you're seeing a 2 100 hertz. That must be the
200 hertz?
second harmonic of the 100 hertz
I
tone.
don't
And
see
what
any
are,
200 hertz.
yeah, right
Oh, wait a minute.
between
Right
0
over
and
here.
4. Right,
But
that,
that's
yeah.
only on the, okay, it's very weak.
Very weak on one side, but present on the other, and it's
Yeah.
coincident with the
Well,
second tones.
yeah, okay. All right. Yeah. Yeah. So
And
these are
what are those lateral splotches out there at like
This,
9
here.
until 10?
Those are the that's the seconds ticks. They're 1 kilohertz
Why are they so wide?
because they're short, right?
I guess so. Yeah.
Uncertainty
The
principle, right?
six cycle tick.
Yeah.
Widen time, or a narrow
Or
in time
narrow in
is
time,
wide in
wide in
frequency, and
frequency.
vice versa, right? So yeah, they're only 5 milliseconds long, so they're going to be roughly what, 200 hertz wide, and then that's roughly what you see.
Yeah, that's right.
Yeah, and you also see them around the well, you see sidebands around the tones too, right? Because the tones are interrupted every time a tick happens. And so that generates sidebands, even though you're turning the tone off, you're still modulating, and it still produces sidebands. So you'll see sidebands around the tones too once the tones start.
You have a
Right now,
very
I think
interesting mix of the two signals there, because right now is only WWVH is doing the tones,
right,
and they're present, but
right,
you're also seeing 1 second ticks.
that's right.
I mean
Those are,
the 1 kilohertz ticks, not 1200.
yeah, which means it's Colorado, which is
Right.
usually stronger here, but not always. But so yeah, I'm weekly seeing WWVH's tones out here, I think. Oh,
Right.
wait a minute. It's 56.
Oh,
No, that's too far
that's
out.
signal one.
Too far.
It's got to
Yeah, that's too
be
far
five
out.
or
No, no.
600. 5 or
Yeah,
600
look
hertz.
at the harmonics. There's the minute beep. You can see that they still have harmonic distortion as well as phase conversion distortion. When you have AM to PM distortion, the sidebands will not be the same. They can be different levels. They're mirror images of each other only when the AM is clean. There's no phase modulation.
So is that why you're seeing a little bit more on the upper side band of the
That could be.
yeah.
I mean, you'd have to average out over time because of the ionospheric fluctuations.
Wonder if they'd be able to pre-distort their signal and get rid of that distortion.
Well, there's no way to pre-distort the audio to get rid of the phase modulation. You'd have to pre-distort the drive through the transmitter,
I guess so.
advance or retard the phase along with the modulation. But I think the right way to do it is to neutralize the final. At least that would improve it. Again, the ChatGPT came through me on this. It pointed me to the theory that explains why this happens. It's the Miller effect.
Right.
You have plate to grid capacitance. Even at tetrode, you have some, and I know they use 4CX 5000, I think, tetrodes. There's going to be some plate to grid capacitance that gets amplified by the gain of the stage. And that causes feedback or varying capacitance that detunes the gain of the amplifier is a function of this plate voltage because it's being modulated. Therefore, the capacitance changes. Capacitance, therefore, detunes the input tank circuit and causes a phase shift. So if you can cancel out that capacitance with a neutralization circuit, you can reduce the phase modulation effect. But I haven't gotten any takers at WWV when I mention this, and I don't really want to, annoy them too much. So that's 5. Let's see. I usually see 25 by this time.
Interesting.
What's that?
There's a little tick there at 1200 hertz.
Oh, so you're seeing Hawaii too.
Seeing
This
Hawaii
is 2.5. I hear Hawaii
on
on
the only
2.5.
the minute tick, so not the second ticks. You're not really seeing the second ticks, but you do see the minute tick.
Yeah. This is 2.5. I will occasionally hear Hawaii here, but it's usually almost always Colorado. And of course, it's weaker. The noise level's higher, and the transmitter is only 2.5 kilowatts versus 10.
And then look at that little signal just up from 2.5.
Yeah. I don't know what that is.
That's sneaking in there.
Coming up on the minute. But notice how much cleaner this is. It's a linear amplifier rather than plate modulated. It's still got some amplitude distortion. You can see it's got a second harmonic in the minute beat.
And that's 1,000. That's all Colorado
Yeah, that's
on
all
on the
Colorado.
minute.
Yeah.
Yeah.
Yeah. I will hear Hawaii sometimes late at night, but on 2.5, but it's usually very low. It's 5 and 10 where I really hear it. And 15, I very often hear Hawaii only. Let's see if 15 is open.
10 p.m. here, WWVH is quite strong just before sunrise.
It's before sunrise. Well, it's after sunset here. Well, I can see the carrier or somebody's carrier, but it's not strong enough to give me any sidebands. If I zoom in, I might get something.
At the top of the minute, we'll see if there's a tick.
Yeah. Well, I'm zoomed all the way in now. Let's see. Am I even going to see 1 kilohertz? I don't see the time code. And usually I will see the time code if there's anything else. So
Boom. That was the tick.
oh, there's the tone. The tone
Yeah.
started.
There's the
There.
tone.
That's a
That's
500
at
hertz tone.
500
and
hertz.
It is that must,
And
that's
there's
Hawaii. That's Hawaii because they transmit 500 hertz on the odd minutes. So it is Hawaii.
and there's
Yeah, very
100.
often on 15, I'll hear only Hawaii.
Yeah, I'm
There's a
hearing
100 hertz
both of
tone in
them
there
on
too.
10.
Oh, yeah, there's some 100 hertz. Now, 10's a problem.
But what's that 2.5? There's a little wispy thing in there. Only on the upper
Yeah.
sideband side.
All right, let me go. Let's see. Here's 10. Hey, this is better than 10 usually looks. I've been trying to get rid of Ethernet noise, so I found out most of it was coming from my Kiwi SDR at 100 megabits. So I switched it to 10, got rid of the spikes every 61 kilohertz, but then guess what happened to 10 megahertz? And megabit Ethernet is basically a 10 megahertz square wave carrier. So yeah, there's a lot of crap above here, so it's not super clean. That's as far as I can go. That's a 1 hertz bandwidth. I could actually make it smaller. There's no limit to how small I can go in these FFT bins. You just have to wait a long time to get a block.
You've got both 500 and 600 in there. 600 is obviously
Yeah.
WWV, but 5 is in there.
Right now?
WWVH. Yeah.
Oh, this is WWVH because this is 600 hertz tone and it's an even minute.
Oh, even minute. That's WWV.
Yeah.
So then WWV is the 500 hertz tone that's real weak there.
Oh yeah, it's in there. It's really weak. Really weak. I
Yeah,
can't tell
here
by
in New
looking
Hampshire,
at
I'm hearing the two of them almost equal strength.
Yeah.
I can't yet tell by looking at the spectrograph whether it's a female or male voice. I mean, that probably takes a little more practice.
But it's when it happens. She talks.
Yeah.
Oh yeah, that's right. That's right. Yeah. Yeah.
Just before the
that
minute.
I
And he talks a
That's
little
right.
earlier.
She talks right
Or
after
she
the
talks
end
a
of the
little.
tone at 45.
Yeah.
Yeah.
Right.
That's right.
And then he talks closer to the top of the minute.
I can echo Dave's comment. In Massachusetts, I get WWV and WWVH many times equal.
On which bands? What frequency?
10.
Right now it's 10. 15 is more common for me. But what really is bizarre is often on 15 I'll hear WWVH and not hear WWV.
You got to
Yeah.
skip.
Yeah, skip. Yeah, you're
It's
too
getting
close.
it's getting ducted.
Now, Dave, you said there was something on the 2.5 that you were wondering about. Is it this line right here? This is
What is
2.5.
that? That looks, is that 2.5 or 3? I can't tell.
Oh, I can see a little bit of Hawaii. I can see their tones.
Yeah. Yeah, there they are.
Or wait a minute,
Up at 6.
Or are they? I may have just gotten fooled because you see
Wait,
the
wait,
sidebands around each tone.
The dots at 4
That's-
could be intermod from that
That's
100
right. I
hertz
think you're
Yeah.
right.
on 5.
I think
It's
you're
a
right.
subtraction.
Well, the 6 is
Well,
there.
let's watch for the minute. The minute tone. Actually, wait, is the minute tone? The minute tone is off the
You're
screen
seeing
here.
500 hertz and a little bit of 600 right there.
Okay,
Well-
I move out a little bit so I can see the 1 kilohertz. Oh, well, I missed. Here we are coming up on the minute now.
Yeah,
Okay, that's Colorado. But I don't see, is there anything in there? I don't see any Hawaii. I don't see a 1200 hertz beep.
there it is.
Well,
It
you
is?
can't tell if that's Hawaii or if it's intermod.
Yeah,
I
It
was
could be
looking at the
Yeah,
minute.
100
I was
hertz
looking at the
plus
minute
or
beep.
minus 6.
WWV is the 600 hertz right now.
Um,
It,
right. Yeah, it's the odd minute.
it wouldn't be symmetrical about the carrier if it wasn't intermod, if it was really WWVH.
No.
See, you see it above at 4 and 600. That
At both 4
Yeah.
and
Well,
7.
I
this
think
this transmitter
that
is clean. If you look at it
it,
on an IQ display, it's pretty much a straight line.
But
I
look at
find it
down
interesting you're
below.
seeing the second ticks on the 600 hertz sidebands.
That's right. Yeah, well, it's interrupting. Those you should see those when you gate the tone off of the tick.
Oh, that's
You're
right.
modulating it.
It's intermittent, isn't it?
That's right. Yeah.
Let's see,
It
there's 5
actually,
plus and
yeah,
minus 100.
it's blanked around the ticks.
But yeah, you see the intermod. You see a little bit
Yep.
of intermod even here.
Yep.
Now, it may be amplitude intermod. I mean, the transmitter is still not completely linear, and that will still generate intermod. But most of it on 5, 10, and 15 is due to the phase distortion. Because you can hear the difference. You switch between sideband or IQ and AM, and the AM sounds much cleaner.
Why are
It's
you
phase
seeing
sensitive.
10 kilohertz sidebands?
10? No, that's one. I mean, I'm really zoomed in. It's just 2 hertz per bin.
2 hertz.
The two strong ones in the center, that's 100 hertz. So each division is 200 hertz.
200 hertz per bin.
Right.
Oh, yeah.
So I'm going out to about
But
1
if you look
kilohertz.
at 2.5010, isn't that 10 kilohertz off?
No,
And
that's one. That's 1 kilohertz off. 2.501 is 1 kilohertz above.
Oh, right.
2.5. Yeah. So you can see the minute tone pretty clearly. I think the minute tone and the seconds beeps are probably the things to use because they're sent alone. Nothing else ever intermodulates with them. And I think they're sent at full modulation. I know the seconds ticks, I think, are set 100% modulation. But the important thing is there's nothing else. So there's no intermod, and you can probably, Scott's been doing this. Have you been doing this too, Michael? I'm not keeping track of who's doing what, but Scott's been getting good results on looking at these seconds, minutes ticks.
Yeah, I've been definitely looking at them. And as I think I mentioned before, the beauty of the intermodulation um, on the 5 and 600 hertz tones is that the 400 and the 700 products are going to be unique to one station or the other, depending
right.
upon on what they're doing. And so if they're strong enough, you know that if there's something popping up on 400, it's coming from a particular station.
Yeah. Yeah, that way you
And
can identify that the station is there, but you could also do that just by listening for the seconds ticks.
yes, but
The seconds ticks.
if they're both broadcasting on the same minute, one of them on 5 and one of them on 6,
Yeah.
those are the minutes when I was looking for something that was also unique due to
Yeah.
that, making the
Right.
intermod not a problem, but actually a benefit, because otherwise I was having to look at the minute when either WWV or WWVH was broadcasting a 500 or 600 tone by itself. But even in the minutes when they broadcast it together, the 4 and 700 hertz intermod products will be unique. So even in those minutes when they're broadcasting together, if they're strong enough, you can detect those and get a measure.
It's a shame to have to throw away so much of the signal because it's contaminated. It's worth trying to recover that.
Yeah.
I mean, the seconds and the ticks and the minute beeps are clean, but they're a small fraction of the total energy that the transmitter emits.
It's interesting. I guess I didn't appreciate the smear that you can definitely appreciate looking at this, and that would be to widen the window, the frequency bins around that 5 millisecond tone. Would that be a benefit rather than trying to narrow
Widen
it
the
in?
frequency bins.
I mean, widen your window and look at more of the frequency instead of trying to narrow a filter down right on around 1,000 hertz or around 1,200
Yeah,
hertz.
yeah.
Broaden it a little bit because it's such a short tone.
Oh, well,
rather,
if you make a
rather
match
than making
filter, I mean, if you have a gated sine wave reference that you match with it, it'll automatically have that spectrum. I mean, when you do a correlation with a local copy, you created a match filter.
right.
You're doing it in the time domain, but in the frequency domain, you've made a filter that has, or a signal that has the same, or a filter that has the same passband as the shape of the signal, which is a match filter.
And that's what I am doing.
Yeah.
And I guess
Yeah.
in that case, the height of the match tells you what the power is, what the amplitude of the signal is, right?
Yeah, what the correlation is, right?
Yeah.
Exactly.
Okay.
Yeah, and you probably noticed that the 2 seconds ticks are designed to be orthogonal. They last for 5 milliseconds. If you integrate 5 or 6 cycles of sine wave over that time, you get an even number of cycles. So one will not contaminate the other. The peaks of one are in the nulls of the other in this.
Yeah.
Which is was
benefit.
obviously designed that way. Let's see, go back up to. Well, I never saw such a group of people fascinated by WWV before. That was what we used. There's 5. Now you can really see the modulation on the. You can really see the seconds text on this one because it's stronger.
I've been listening to WWV my whole life, I think. At least since I was 11 or 12.
Yeah. The bouncing that you see on the subcarrier tones is probably because of my window. I'm using let's see, at the moment, probably a Kaiser window, and I have it partially overlapping, but its response over time is not constant. So when you have a pulse signal like that, you'll see it sliding through the shape of the window and causing that variation. I mean, you can fix all these things. It just takes more CPU cycles, and it depends on how much you really care about them.
They're announcing our modulation right now.
Ah, okay.
Another 4 minutes, we can watch it.
Yeah, right. You guys go to the TAPR-Ham. I know much of you guys went to the TAPR-HamSCI banquet at Dayton when I spoke.
Yes.
I didn't know that Christina Collins was in the audience. If I'd known, I was going to make a joke at her expense by saying that, at night when I go to sleep, all I can hear in my head is the following is a scientific modulation test. Well, that's usually the voice I hear, along with the voice coming from the other room saying, "Go to sleep." Both female voices for some reason. Yeah, here you can really see the intermodulation distortion on the tones.
Oh, yeah. Yeah.
Plus or minus 100 hertz, very clear. Even though the other station I don't think I'm receiving right now.
Yeah, you can see both 4 and 7.
Yeah. Oh yeah.
Very light on 4, but it's stronger on 7.
Yeah, let me check the window setting again. This is a Kaiser window beta 7 that pushes the side lobes down around 70 dB, which seems to be pretty good in practice. Much more than that, you're kind of just wasting it. The problem with Windows is, with Kaiser, there's a tuning knob that allows you to do this trade-off. But with any window, there's a trade-off between the width of the main lobe and the height of the side lobes. The cool thing about Kaiser is you can make that variable. If you set it to 0, you get a rectangular window, and I'll show you what that looks like. Let's see, 0. There we go. That's a rectangular window. See what happened to the main lobe? It got narrower. The peak got narrower, but then there's always crap around it. And this is what I had been doing. The spectrum analyzer, the first one I did, always worked this way because there was no way to apply a window. It was using the was piggybacking on the FFT that the correlator uses for down conversion. And I can't modulate that without destroying its use as a down converter. So the only way really was to do a whole separate bunch of FFTs with Windows just to build a spectrum. So that's rectangular or Kaiser with it's Kaiser with a beta of 0, which is the same thing as rectangular. It's a flat window. Let's see what other windows do I have here. Let's see. Hamming. That's an interesting one. Most people know. It has an interesting little quirk. You see a little notch in its side lobes if the signal's strong enough. You can almost see it there.
That's
You
real
also
tight, narrow carrier, though. That's
yeah. Well,
yeah.
the Hamming window, it has a narrower main peak but higher side lobes, and the side lobes, in my opinion, they're like 30 or 40 dB down. They're really kind of too high for this.
Christine is about to come on.
Yeah,
All
right now,
okay,
this minute.
what window you guys want? I'll just leave it in Hamming here.
We should
Voice.
see the
Yeah.
10 past. We should start to see the test signal.
Well, the sleep rate isn't as fast enough here to really see the chirps, but you'll see them. Where is it?
There it
Oh,
is.
there we go.
There it goes.
Yeah. Down sleeps, yeah.
You get some noise.
Yeah. That's it now. Okay, voice now.
Yeah.
All right, let's see. So yeah, I know the sampling window stuff is down in the weeds, but sometimes you have to pay attention to detail. It's also a Gaussian window, which I haven't played with before. That's a Gaussian window with a parameter 0, which is pathological. Let me make it about 2.5.
Oh, it's beautiful. Looks like a sunrise.
Yeah, right. No, a Gaussian window with a sigma of 0 is a Dirac delta function. So it's infinitely short in frequency, which means in time. So it has to be infinitely wide in frequency, and that's what you saw. The side lobes basically cover the entire spectrum.
So were you just changing that in the control
I was doing it through my control program.
Yeah,
I
okay.
would like to bring these controls out, have them up on KNIQ Web, but things here are already getting kind of busy. I mean, there's just so many tweaks inside KNIQ Radio.
Well, I may try to do it in that little interface I was building.
Okay.
That you saw last week.
Yeah.
It's that last week. That's just sort of a passive display. It's not interactive, but I could probably make it interactive.
Now, Gaussian doesn't have any nulls. It just, the Fourier transform of the Gaussian is a Gaussian. This is an approximation of a Gaussian because the Gaussian is infinitely wide and the window here is finite. But you get this smooth roll off of the main lobe with no side lobe. It just continues to decline. And you can change that trade-off by changing that parameter. Basically, it's a Gaussian function and changing the standard deviation. Let's see now. Blackman is another pretty good window. It's a pretty good general purpose window. That's Blackman. You see that one pretty much is the default on a lot of spectrum analyzers. I think it's the default on the QESDR. It's got pretty low side lobes. The main width is kind of wide. You see, but the side lobes are very low. And really, it's the side lobes are what you care about because once they're in there, you can't get rid of them. You can always make the main lobe narrower just by making using a longer FFT and keeping the side lobes at the same level. So I generally go for windowing functions that push the side lobes down below the noise, and then I just change the time scale if I want better resolution. But yeah, look at all that stuff.
Yeah, that's a crisp signal, nice and strong.
Yeah, but are we seeing Hawaii too? Let's see. Move my other window out of the way. No. Oh yeah, we are. Okay.
That's 12.
1200. No, wait, that's a harmonic. That's the second harmonic of 6. Never mind.
see if there's a second tick
Yeah,
up
it's gonna be
there.
up in a minute here.
Boom.
There we go. Okay, there's a little bit. You
A
can see
little bit
a
of
little bit of
Hawaii
it.
there.
Yeah. Uh-huh.
Just on
That's
the
probably
second
your
tick.
most reliable indication is that minute beep. It's got a fairly large amount of power in it, and there's no intermodulation that can create it.
Mhm.
So, unfortunately, that won't tell you second by second, who is stronger and who's contributing to the carrier. So,
I am
working pretty much as expected.
I'm gonna hit the rack. This is all making me very sleepy. Go to sleep.
A lava lamp.
Yeah.
Talk to you guys later. Thank
All
you.
right. See you, Mike. Thank you.
See,
Oh, isn't that working? There we go. Kaiser window was 7. I have to restart the demodulator every time I change something here, and so you see a glitch in the waterfall. I could fix that, but it would just take more work. But yeah, this can be hypnotic just watching this. I'm thinking about doing some sounding experiments on HF. If anybody's interested in working with me on it. Basically sending a PN sequence and a 2.8 kilohertz bandwidth, and then resolving what comes out at the other end. That would allow us to resolve multipath components up to about a few hundred microseconds, if that's enough. Well, we often see selective fading, less bandwidth than that. So yeah, it should be enough to resolve them. I have a lot of experience with direct sequence from my early days at Qualcomm, so I know how it works and how to implement it. Been wanting to do time delay measurements, right? Absolute delay, as opposed to just Doppler. So we got to start working with signals like that. Let's see what's going on. 10 now. Still kind of weak, and I often see a lot of crap on 10 megahertz. It's not my reference oscillator. It's 10 megahertz, 10 megabit Ethernet or something like that. Everybody wants to put everything on 10 megahertz. And there's some continuous spurs. I don't know where they come from. See if I start zooming out here. There's some artifacts in KNIQ Web, and I go full span, probably because I'm not using the sample rate everybody else is. I'm using 126 megahertz. I go all the way out. There's zoom 1. There's something wrong with that. So Scott, are you listening? Yeah, it's weird looking.
Yeah.
There's obviously some bugs here. I don't understand. It's also going below 0, which you shouldn't do. Here, now if I go to a span that is reasonable, the span is now, what is it? 64.8 megahertz. Yeah. So now the span is actually reasonable. It gives me a reasonable display. There's the whole thing. Once again, that border blaster in Mexico is the strongest signal I see despite Paul's filter. And at this wide span now, the spectrum is a lot smoother because of the averaging. At this level, I'm doing averaging about 100 FFTs, which will knock the variance of the noise down by a factor of 100 or the amplitude by a factor of 10. So that's why it looks so much cleaner than it did before. That's California Highway Patrol. They have a couple of repeaters on a mountaintop near about 6 kilometers from here. They caused me a lot of image problems before I went to a higher sampling rate. One of them aliased right down on WWV on 25 exactly for the sample rate I was using.
Is WWV still on 25?
Yeah. Oh, yeah. WWV's been on 25 unofficially for years. I mean,
Well,
they officially shut it down a long time ago, but it's still
yeah,
up.
but I heard something just within the last few weeks that made me think it was not on anymore.
I heard it recently,
Okay,
as of
okay,
this weekend, I think. I
okay.
usually don't hear it, even when I hear sea beers on the East Coast, I don't hear it here because I'm too close. I'm inside the skip zone.
No, I've been hearing it during the day here.
Yeah, you're
Oh,
farther
okay.
I
away.
heard it this today.
Yeah, you're farther away, so you're more
Right.
likely, you know,
Yeah,
but
well,
it's
I usually
relatively
hear
underground.
it, but I just saw something or I just don't remember what it was, but it made me think that it was not on. Uh,
No, it's on. I don't know
yeah,
that it's ever been turned off. It's just not officially on.
maybe that's
Well, there was a period it was not on, but then they
Oh,
yeah.
put it on as on a. It's technically an experimental station,
right. Yeah,
which
I
it
think it
was
was
explained that that means there's no backup for it.
that's right. I remember Matt Deutsch, it seems to be his personal pet project is that 25 megahertz transmitter. He told me it was really working to get it on during the eclipses, but I don't think anybody ever heard it anyway. I mean, if anything, propagation to higher frequencies would go away during an eclipse and not
Right.
strengthen. Yeah. I don't know what this crap is. It's periodic. I mean, you get higher frequencies, instead of switching power supplies, you start to see computer emissions. They start
Didn't
sounding like digital signals, which is what they are.
did Mary Lou do something with the 25 megacycle signal in the eclipse, or was it just 20? Does anybody remember?
Well, everybody with Triple H tried to receive them all, I believe.
Yeah, well, she did a presentation at the workshop, and I
I
was trying to
remember.
remember if it was 20 or
Oh,
25, but I
oh,
thought it was 25.
yeah.
Well, at least one of the eclipses there was some 25 leaking through. I think Nathaniel was showing it.
Yeah, this is all crap in the middle of 10 meters, and it's periodic too. I don't know what it is. But man, I couldn't believe this section yesterday. I've never seen 10 meters that active. Took a couple of screenshots. Let's see. Here's the bandages. Here we go. Playing with those a little bit to make them a little easier to see. It's 10 meters, 12 meters. I went in and added the new frequency limits for 60 meters. And then I got a message on Signal from Wayne saying, "You broke the president." I love the Fire Sign Theater reference. I didn't think anybody remembered that anymore. Remember that? You broke the president. I had syntax errors in JavaScript.
Trapped like Mars flies in a Klein bottle.
Yeah. Oops. When did that happen? There we go. Zoom center. Zoom in. There we go. So this is the markings I now have. It's good as any for 60 meters. Because I can never remember the frequencies on 60 meters. Never. So channel one, channel two. Channel three is now the new 15 kilohertz wide QRP band, and channel four and channel five. I never see any activity here except FT8 and Whisper on channel three. Rarely do I see sideband on the other channels.
Well, at least once it takes effect, there will be a legal and usable whisper frequency for 60 in the
Yeah.
end.
Now, do we really think that everybody's going to obey the 15-watt limit?
Um, I determined a long time ago that most hams can't do math.
That's right. Well, if they run a 100-watt transmitter, it doesn't really take a lot of math to know that you're probably over the limit.
Yeah, unless you're running mobile.
Yeah.
Well,
Yeah.
what's interesting is all the power limits are in ERP. So you
Well,
have to double your
it's
antenna.
EIRP and ERP, both are quoted. It's 15
Right,
watts EIRP, and then somebody did the calculation for a dipole and
right.
gave ridiculous precision in the rules.
Well, yeah, at least in the report in order, they do spell out specifically that it's a dipole reference that they give
Yeah.
you for the
Well, I think they actually get both because it's a
yeah,
round number. It's 15 exactly in EIRP.
whoever wrote the discussion was thinking ahead and assuming anybody reads it explains why it's 9.15 watts is why the
Yeah, it's the gain of a dipole, right? I still get, there we go. This is where I wanted to be. I don't know if this is FT8 or, no, wait a minute. There it is. Okay, it is FT8.
I don't I haven't found where it's been published in the uh,
Federal Register.
right,
Yeah, I haven't seen the official dates yet. It's supposed to be 30 days after publication in the Federal Register.
and I don't
I,
have a good feel as how long it takes
yeah.
after they publish the report in order before it appears.
I haven't seen anybody using these pieces of the side here. So either they haven't heard about it or they're, being patient. This guy over here is always there at night. I don't know who he is, but probably military.
Oh, that RIDI station.
Yeah, always there. Along with the Japanese pinball machines. That's one of the weirder sounding digital signals on HF anybody's heard.
Oh
You
yes,
know
uh,
the one I'm talking about?
yeah. I get it's a group that I'm in gets on 60 meters channel 4 Wednesday nights, and you can often hear that burbling away in the background, which doesn't seem to me like it ought to be propagation to Japan quite yet.
No. They have a list of specific frequencies they use all the time, and there's a bunch of them around this area. But it's a very distinctive sound. Their idle pattern is this like tune that repeats over and over again.
Uh,
And then when there's data, you can tell that there's an interleaver. You can hear the interleaver filling up. And then the message is just noise. And then at the end of the message, you can hear the interleaver emptying.
mhm.
I haven't heard anybody comment on that, but I think that's what it is. Guys, there's so many different digital modes on HF. You don't even know which ones to experiment with. I was thinking of doing an OFDM mode, and then I started reading about the problems with peak to average power ratio, and I think it may be almost intractable. There's a modification called single carrier FDMA, which involves some pre-coding for OFDM. I don't fully understand the math. I accept that it works, but that still has peak to average power ratio that's less than 1, but it's better than straight OFDM, which is more like Gaussian noise if it's wide enough carriers. So now I'm reconsidering single tone modems. I always thought that equalization on HF was just impossible, but it's being done. Maybe it's worth looking at again. Or just sounding the channel with a PN sequence and using that to train a equalizer.
Do you know much about the RAID mode that David Rowe and company are using?
Oh, RAID?
Yeah.
Oh, yeah. I talked to Dave quite a long time when he came to Pacificon a few months ago. I mean, I know how he's doing it. He basically just took a large language model, said, here are your constraints. This is the bandwidth you can use. This is the signal-to-noise ratio you can expect. And I want you to keep the peak to average power ratio within 1 dB and then generate whatever you want to generate to make the voice that comes out the other end sound like what went in. And then he trained it with like 200 hours of synthetic speech, which takes about an hour on his GPUs.
Well, is the RAID thing integrate the speed? Well is it? the previous one was the modem and the coder were
Right.
separate.
Now he's doing joint coding.
Okay.
That's what I just described as this joint coding project where RAID itself gets to figure out what to send on the channel. So all you see is just noise that is band limited.
Mhm.
There's no discrete spectrum. I mean, it's obviously coded, but it's coded in ways that only, the large language model was able to figure out. So it's probably effectively encrypted unless you have the training model. Of course, he's publishing those.
Right.
The training model, well, I mean, the results are always good as whether the training model matches the channel that you've got. So you have to give it synthetic fading and noise. And you can probably do multiple ones for different kinds of channels and switch between them. That would kind of make sense. But I was really impressed when I heard it. I don't know if anybody else has heard RAID, but it's kind of eye-opening what you can do.
Right. I have heard the demonstration files.
Yeah. Um, I thought about, using it to design a modem, but I talked to Dave about that. He thinks that actually, the analytic design we've used so far for modulation and coding are so close to the Shannon limit that you probably can't do a whole lot better with a large language model. The reason why his RAID stuff works so well is because lossy voice codecs are still nowhere near their limits.
Hmm.
RAID is just finding other ways of doing them. Well, but on an HF channel, though, I mean, things are so variable. I'm not totally convinced that our analytic methods really are, close to what the true Shannon limit of the channel would be. It's so variable. What you kind of want to do if you had an unlimited amount of processing time is to create a model for the specific channel you're going to use and then use it, exchange it and use it. Of course, these models are megabytes, so I'm not sure how you would send them over HF to the other guy.
Well, I still haven't figured out the intractable problem of the nature of your channels continuously changing. I mean,
Yeah. Well, that's what I said about the dynamic equalizers, right? It's that
right.
you have to track all that. But I think you model it actually as multiple paths with randomly varying phases and gains. And then that recreates the nulls and the Doppler shift and all the other effects you actually see. I'm wondering whether that might help me make a better PLL. I implemented the synchronous AM quite some time ago here with a simple PLL that locks the nominal frequency to 0 hertz. And obviously it works fine on a local AM radio station, but I don't need it on a local AM radio station. I want it on HF. But on HF, when you get a deep fade, the phase flips 180 degrees because the fade is usually due to two paths that cancel each other out. So when you go through the phase slips, and if the PLL bandwidth is tight, it may have trouble flipping around to track that phase. And I'm wondering if you made an intelligent PLL actually knew that it was dealing with an ionospheric channel and it tried to model its state and then generated the phase from that, whether that might work better. That'd be an interesting project. I mean, something simple as a PLL still has more work has more theoretical work to be done.
Right.
Oh, you want to see FT8? What about now? 40 meters is the place to be. Yeah. Yeah. 40 meters is by far the most productive band at night for FT8 for me.
You'd think 30 would be
30 is pretty popular too, but 40 seems to beat them out. Probably no power limits, maybe. I don't know.
not if people are running more than 200 watts. Very
Probably.
poor. I mean, you can't hear them if you can't work them. So,
That's right.
well, whatever it is.
Can't work them if you can't hear them. Yeah.
Yes.
I can always zoom in on these. Well, that's 2 hertz per bin.
So,
Now, you have to remember also that because of the windowing, the bins are actually wider than 2 hertz. They're actually more like about 3. So there's a 2 dB adjustment you have to make an energy or a noise energy here. It's something else I want to bring out through the Key and IQ web interface.
right.
But Yeah, it's just close stuff. And you can easily see the modulation in individual tones. Two words per minute, and I'm averaging four. Let me back off on averaging a little bit here. There's no averaging. Now what you're seeing is each update at 100 milliseconds is two overlapping frames, each a half second long, that are then averaged. So the actual bandwidth of resolution bandwidth, well, the bins are 2 hertz apart, but the actual bandwidth of each bin is more like about three hertz or so. Let's see what happens if I turn off the window in this. It might be interesting. See, rectangular window. There we go. See that the lines got narrower. Once in a while, the rectangular window, as bad as it is, sometimes it's the right way to go. You're trying to separate two signals that are about equal strength, but are very close in frequency. The rectangular can often reveal it. Or you just, use a longer block and get more resolution that way. Okay, back to my default window is Kaiser or Beta 7, which is pretty good. It pushes the side lobes down around 70 dB. For the channel filters, which I compute on the fly when you change the bandwidth, like here, I use default Kaiser of 11, which pushes the skirts, the side lobes of the filter down to about 100 dB or so, which is plenty for just about everything. I worked with Jim Kaiser at Belcore, by the way, back in the 80s. He's a nice guy. He's one of those guys that never wanted to do management, but was just happy to talk if you ever he worked alone pretty much. But if you stuck your head in the door and asked a question, he'd be more than happy to explain something to you. I always like guys like that. I know a few of them at Qualcomm too. Dennis Ritchie was like that. I know him briefly at Bell Labs back in the early 80s.
Was seeing now on last Wednesday, Scott and I got into a discussion of, I mean, apparently it was mentioned elsewhere, of trying to use the dead time between whisper transmissions to do figure out what to put in there to do time of flight that would be practical yet fit in the 200 hertz bandwidth.
Would that screw up any whisper receivers? They may use that time for noise estimation.
That is true. That is true, but with K9Q, that's or an 888, that's probably less of an issue because you could always park it somewhere else.
Yeah, sure. It doesn't have to be in that band, sure.
But what's more valuable? I wonder a noise measurement or being able to get some sort of approximate time of flight for existing like whisper sounds.
Well, the noise measurement is important too. People want to know the signal noise ratios. I mean, the JT modes are the first modes ever in ham radio to have honest RST reports.
You could alternate.
Right. Well, yeah. Well, I mean, what Scott and I were talking about was that you could not only have schedules like which 2-minute interval a particular station uses or doesn't use, but you could probably have offset whatever modulation you have by by a few hundred milliseconds to make it, depending on the station, to make it more orthogonal, so you don't.
Yeah, but the bandwidth is so narrow though that I don't think you really, and the keying also, if you look at it, it's continuous phase with heavy filtering to keep the bandwidth small. So I don't think you're going to get a lot of good timing resolution on that.
Right.
You just need a signal that's designed for it.
Excuse me?
You need a signal that's designed for timing, and that means wide. And the widest we can do in HF is 220 kilohertz, and we can probably still do something with that under the new rules. We can do more than we could under the old rules.
Right.
So this is Whisper on 40 meters with a 1 hertz pin. What's the step size? It's like a hertz or so, hertz and a half.
1.38.
1.38. Okay, so yeah, it's within the window lobe here. Let me try rectangular windowing and see what happens.
When
Oh,
I
it's
look
good.
when I look at this waterfall, it kind of hurts my eyes because it seems like I look at it and my brain tells me that it's all out of focus it, but then I look up at the numbers and they're sharp. So
Yeah.
so
You
it's
see now how these lines are sharper. You can see the FSK a little more clearly. That's because I've gone to a rectangular window.
right.
So now the bandwidth of each band really is 1 hertz. Everything else broadens it.
Is it 1.38 or 1.46 hertz per step? I think it's actually 1.46.
Oh, you're seeing it here because there's 4 tones, right? It's four area and yeah.
I think it's actually 146 per step.
But yeah, you can see the modulation more clearly here with and the side lobes aren't much of a problem because the signals are weak anyway. They go down the noise pretty quickly, but you can certainly see the side lobes, this yellow stuff on either side here. That'll go away if I go back to a higher beta value, but then the midline will get thicker. I might hack this down to a bin width of half a hertz. The only numbers in the program.
Yeah, there it is. 1.4648 hertz, roughly.
Okay. So it's changing. Okay, I'm integrating over 1 second then. So it's changing within a second. But yeah, it's comparable now. The bin size is the noise bandwidth is now comparable to the modulation shift. So you can actually see it. Before it's kind of just a blob. So if I go back to my usual Kaiser beta of 7, you see it thickens out, but the crust around it goes down, but the main line gets a little thicker.
Yeah, it's exactly 12 kilohertz divided by 8192.
Okay. That's usually where funny numbers like that come from.
Oh, yeah.
Math using powers of 2. I think you want to keep his FFTs to be powers of 2, which is a reasonable thing to do in design, but FFTW seems to work just fine with other numbers that are, as long as they have small prime factors. The rule is anything up to 11 and 13, you can have either one factor of 11 or one factor of 13, and as many smaller factors as you want, and it'll still run fast. Oh, that reminds me, I made a change a while ago. I don't know if I really published this, but every time KNIQ Radio generates an FFT for a new size, it logs it in a file. And you can then run a command line that will go through it and run wisdom on all of them automatically one at a time. So it makes wisdom generation a lot easier.
What was that?
What's that?
Now run that by me again.
All right, let me bring a window and I'll actually demonstrate it here. Let me switch windows. Stop sharing this one and see if I can figure out which window I want to share now. That one. This one, I think. Yeah, here we go. Maggie. Okay, that's the machine that's got the blade on it. So if you go into Verilib, and with these keyboard condoms on my laptop, it does make it a little hard to type on, but it's something I have to have. Let's see. And if you radio in here, you'll see a couple of things. You'll see the spool directors for FT4 and FT8 are here.
Right.
The wisdom file, the application specific wisdom file is here. There's also a Whisper directory. And I think I just parked that file there to say, but the file you're looking for here is fft.log. However, I've zeroed it out. But if you look at the old one, you can see a list of these FFT sizes. This is using the FFEW notation. C or R for complex or real, O for in place or out of place, F and B for forward or backward, and then the number of points. So what I just do is a command like this. I sort unique, which gives me a unique list, only one entry per, and then I can run that into a program called FFT gen, B, and it'll run through and generate them all. And for some reason, I seem to have gotten a huge one on the list that I don't really need. Is spurious. I think that's why I wiped it out. So I'm going to abort that.
I
But you
mean,
see how that works? It's a lot easier now than doing it before.
what on earth? Oh, COB5 is used for.
I don't know where that one came from. I mean, somebody's, I think, got in there when I was just playing around with buggy Windows code, because every time you change the Windows span, you generate a new FFT. I did verify with the new Zoom settings I have. I did verify that all the FFTs that are requests are friendly. They all have small. I think the largest is 13. A couple of them have 13s in them, but you can have one of those. So this works pretty well. It also checkpoints every time it does one of these. It updates the wisdom file so that if you kill it, you won't lose everything. To start all over again, like you do with FFEW wisdom. That was really tedious. So anyway, it just appears here. If it's not already in the wisdom file, it'll log it and then use an estimate. And then periodically you can go through here, take a look at that file, sort it, unique it, and pipe it through that program to generate the wisdom and then blow away the file if you want. It doesn't hurt to run it again. If you regenerate wisdom at the same level for one that already has, it just completes right away. As you can see here, it just ran through all those other ones and then it's stuck to the one at the end because it hasn't actually done it. That's 126 million. I don't obviously that's my sample rate, so I must have generated that somehow by mistake. This is running on one of those B-Link boxes that Rob likes.
Right.
Bought a bunch of them recently.
Now, we determined in northern Utah that some of them have inadequate cooling in their power.
Oh, I'm not surprised.
And we cooked one of them and maybe damaged another one. But
I'm terribly surprised. Let's see, where's my spec
although,
thread?
so we got one replaced under warranty, which is like pulling teeth. It took
Oh, yeah, dealing with a Chinese company, I can imagine.
right. But to their credit, after sending the totally wrong machine, they took it back and sent the current version, and it looks like they redid cooling on power supply, removed the SATA port.
Oh, there it is, spec 1001. It was using 0.7% of a core. That's what's generating the spectrum display. It's so low because the resolution bandwidth is very small, and the channel that it's using, the down converter channel, is very narrow, need to be narrow, and it's only executing at 10 hertz.
Right.
If I zoom out, you'll see that number go up. If I zoom out to, let's say, resolution bandwidth of a couple kilohertz, or let's say maybe 500 hertz, which pushes into the wideband territory, the default setting, and then go back to, there we go. See, now it's up to about almost 9% of a core.
I'm guessing it's that very reason why some of the clones of the web SDRs require the GPUs.
Yeah, I can see why. Well, here I'm trying to do everything on a standard PC instruction set, because then I don't have to spend the overhead of sending all the data to the GPU and getting it back. And I'm not sure it's worth it for small FFTs. And I want to make this multi-user. I don't want there to be just one or two users running KNQ Web. I want to support as many as I can. I got a lot of cycles. I mean, given all the things the machine is doing, look, it's still got, almost 90% of the machine idle. This machine is processing an RX 888, is decoding all the FT8 and FT4. I don't think I'm doing Whisper at the moment. Is doing HFDL, You can see the HFDL threads running occasionally. They don't actually take that much. They're modulating all the FM channels on 10 meters and 6 meters. Not that there's much activity on any of them. And it's also yeah, it's recording. I think it's recording some local FM repeaters. That's what PCM record is, and it still is, got almost 90% of its cycles left. It's amazing what you can do when you get a good algorithm running on a fast computer.
I gotta go, gentlemen.
All right, see you.
The wake up's coming early tomorrow morning, so I gotta. But this has been interesting. Take care.
Take
Have a
care.
good holiday.
This is the spool director for FT8. Every 15 seconds, creates a new set of files, and they grow. And then they.
Did you ever make it so that you can send the demodulated FT8 stuff to Gladstone?
Oh, it's been doing that for a long time now. Yeah, all my stuff is there. And I'm doing it from all the other stations that I maintain, all the KFS antennas, the KPH antennas, DP0, GVN, and VY0 ERC are all sites that I manage, and they're all doing this.
To like the guy that was asking about the Sotomate, where they encode telemetry on the.
Oh, you mean the extra stuff? Oh, okay. No, I still haven't done that. Sorry. I get sidetracked with so many things. You can see how these files are not the same size because I do different bandwidths on each band. Rather than chase down every one of the Fox sound segments, I just say, yeah, grab 100 kilohertz starting here and just look at the whole thing. It doesn't cost much.
Right.
There's only one FT8 decoder running for all of the bands. And so you can see when it starts up, the temp files have become WAV files right there, and then done. I mean, they're already gone. They're already decoded.
Right.
So a single FT8 decoder wakes up every 15 seconds, does all the bands, and it's done within a second. Like that. Same with FT4. Whisper is a different story, of course.
Yeah.
Whisper is a real CPU pig. Partly because he's using my old Fano decoder. It's an ancient code that really shouldn't be used anymore, especially on HF. So I've been having fun. I'm keeping busy. I hesitate to getting sucked into actually writing code in KNIQ Web. I'm trying to get the other guys to do it. But, it's a matter of personal preference whether you want a feature or not. So, especially user interface. Just hate doing user interfaces. Oh, there's some DRM I didn't know about.
Phil, I'm trying to sync the recordings at Northern Utah with Clint's Clicky Box.
Yeah.
And I'm seeing that when I start the recordings, the RTP timestamp for the different channels in the same channel group are not the same. I'm trying to
Really?
think how they could be off.
Oh boy.
It's a sample count. And I know I sent in a patch that you accepted to advance them if they start on different blocks. And I verified that, My system here, they're all the same, and it's been running for probably 3 weeks.
Hmm.
But I mean, I'm seeing over 10,000 samples difference between, different WWV channels, and that's nearly a second. I did look at control to see if there were any dropped blocks, and I think one channel had 3, a couple had 1, and the rest had 0.
Something's getting buffered somewhere. A second? I mean, the only time I ever see delays like that is when I'm streaming Opus, with OGG over a TCP connection.
Yeah, this is TTL 0, so
Yeah,
it's all
all
local.
local stuff. Yeah.
And I have not restarted Radio D to be sure they start in sync and, see if it gets out of sync.
Yeah.
But it's definitely weird. And I'm just thinking if there's another reason that could cause them to be out of sync that I'm missing.
I
I mean,
don't know. I just
obviously,
haven't looked at PCM record in a while.
well, but PCM records just using the RTP stream that's being given.
Yeah. Well, remember,
So
it also tries to correct the absolute time it's carried in the status packet, and that comes from NTP, which can be
yeah,
bad.
I'm looking at it, but I'm not doing much with that. That's on the list. I need to
Yeah. Well,
I need to
NTP
work
can be
there.
wrong, right? I mean, I've seen it go off by seconds. It
Well,
doesn't stay there usually, but
okay, that's another thing. This box was not running NTP, but now it's running Cronny. So it was
chronic.
off
Yeah.
over 100 milliseconds, and now it's a lot closer.
Switched over that too. You see how you
But
identify a DRM signal? This is one I just found on 5980. The carrier in the middle is from a co-channel interferer. That's not DRM leaves a hole there for just that reason. So that's somebody else. But there's a pilot at 750, 2250, and 3 kilohertz. That's how you recognize a DRM signal. And there are lots of other pilot channels too, but they have modulation on for gain and phase references. But this is for frequency acquisition. So that's characteristic of DRM. But it's almost never strong enough to decode. This is probably not strong enough to decode if I had a decoder here. Intriguing format though. I know some hands that play with it on the air, but they stopped. I don't know why. Maybe the thing just wasn't designed to be a ham mode. It's designed to be a broadcasting mode. But yeah, looking at this late at night is like watching a lava lamp. You could probably use this as a signal opportunity as a monospheric probe, especially if you can recover the data. Then you know the signal that was transmitted exactly, and it makes it a better channel probe than just using the training symbols. This is what it almost always looks like in this part of the spectrum at night. Same monospheric pattern. The high bands at the daytime, you start to see Venetian blind effects. There's probably just 2 major paths that are slowly moving. Here's probably many, a lot of scatter. OFDM is designed to try to just hide the effects of multipath, throw it away. With direct sequence spread spectrum, you can actually take advantage of it. So it'd be kind of fun to play with not only a direct sequence correlator, but a rake receiver that can receive multiple multipath components and sum them together and actually add them up. We did that in CDMA with 3 channels, 3 fingers. What I was looking for isn't there yet. Usually later at night, 6050. Yeah, it's Radio Marti. And then the real puzzle is this one, but this one doesn't come on until very late. 6140 is North Korea. Even when it's strong enough to decode, it won't decode. ChatGPT claims it's because they're just sending garbage as the data stream, and it won't decode because the CRCs don't check. And claims, though it doesn't provide any sources, that some DRM transmitters have gone that way for years. The engineers turn them on and make sure the power is slow in the antenna, and they never listen to the on-air signal.
if you've ever listened to Voice of Korea, you can understand.
Yeah, yeah, yeah. That's a strange country.
They used to have, 50 minutes of propaganda per broadcast, but last time I tuned in, it was like if if there's anything at all, it was maybe just 3 or 4 minutes of their news in quotes, followed by
Right.
weird classical-esque music that all North Koreans seem to be forced to listen to.
Or those, praising Kim Jong-il songs and marches
Right,
that they always play at the beginning. Yeah.
right. Either they are, it seems to fall in the category of three women singing in unison, uh,
Yes.
over orchestrated piano arrangements,
You
or
see, you see North Korean television, right? That lady in the pink kimono, or whatever it is, who has this incredibly hysterical way of talking.
just like everything is so damn serious.
Yeah, yeah. Well, like when she announced the death of Kim Jong-il, oh my God.
Right.
Did you get that worked up over a dictator?
If there was I mean,
I
if you
might be happy, but showing people in the streets crying. I mean, come on. I mean, I would probably be dancing in the streets, but kind of got these all over HF. I wish I knew what they were.
the you're switching supply harmonic.
Yeah. They're so regular that I wonder if you could make an algorithm that would actually cancel them out.
I mean, theoretically, they'll be well, practically they'll be equal to each other except in amplitude, right?
Pretty much. I mean, there's probably very little change from one harmonic to the next, except in amplitude.
Right. I mean, you ought to be able to come up with a model. I mean, you ought to be able
Yeah,
to create the original signal easily enough.
maybe. Go down here. I mean, I have not pulled the coil out of my RX888 yet, which is probably why I see very little down here.
It
We're-
really have much effect until you get down below 200 kilohertz.
okay, well, let's go down here.
But the thing
Yeah,
is,
I see this. I can see it go. Is this it? Is this the reason it's going down here? Is it that bias T?
well, once you get below, let me bring up my. I measured this. I have it on my blog. Let me just see what it is. Let's see here. Frequency spots of the 888. There it is. So 300 kilohertz is down by about 7 dB, and then it stays 15-ish until you get down to about 25 kilohertz. Then it plummets with
Yeah,
with the inductor installed. But
there's that range. There's DC on the left, which I suppress, but you still see the phase noise around it.
right,
I don't know if any of these are.
but you probably have transformers or splitters in line, which are going to knock it out far more.
Well, I have an active loop antenna, and then I have one of Paul's filters
But you don't have. Oh, so you
with
don't.
the preamp, and then it goes
Oh,
into
the preamp would have its own bias D2,
yeah.
which
I mean, there's no need for the bias T in the AAA. It's kind of useless. The bias T in a HF receiver is kind of useless.
yeah, I mean,
Who needs one, right?
yeah, the fact that it's even there tells you a bit about people who designed it almost knew enough to know what they were doing.
Well, I mean, it probably seemed like a good idea at the time, just like the attenuator. You might have some
Well,
odd
the thing that
circumstances.
to me is that when John Siemens redesigned the Kiwi, he included the attenuator,
Yeah.
and I think Glenn Glenn Elmore suggested not, but he wishes he hadn't, because that's the first thing that gets blown up in Kiwi
Oh,
when somebody accidentally transmits nearby.
well, yeah, the attenuator is the first thing it sees, but hey,
Right,
If you can make it can make it an RF fuse, protect the rest of the radio.
but it's not user replaceable.
Oh, yeah. That's probably a
As a normal Kiwi, you could probably dump 100 milliwatts into it and it wouldn't blow it up. I don't recall people have blowing
hmm.
up Kiwi front ends particularly.
These have got to be switching fundamentals. I don't think I'm seeing any of the Navy stations. What are the Navy
Well,
frequencies?
so that switching fundamental you're seeing there is definitely not the one you're seeing higher up.
No, well, 32.4 kilohertz.
How stable it is.
Yeah, right. It would be even worse. It's probably just wideband hash by the time we get up to HF.
Yeah.
Now, some of these might be intermodulation products too. Like I don't know how linear all those amplifiers are. See if I can even see WWVB. Occasionally it pokes through. I don't know what this is. This is an odd little artifact. Noise dips down, then there's a peak here. 38.1 or thereabouts.
Let's see here.
It's odd looking, isn't it?
It'd be interesting to see if that went away when you disconnected or powered down your antenna.
Yeah.
That is awfully sharp.
And it's odd to have an artifact that narrow and it's right next to a noise peak.
What it reminds me of is that asymmetry you get when you have a resonance.
Yeah.
You get a peak on one side and a notch on
And dip on the other, like with a crystal, yeah, you get series and parallel resonances.
right, or in a duplexer on a repeater, you get the same thing.
Yeah. I don't remember the VLF Navy frequencies offhand. I know I went 40. So I don't
No,
think I see them.
they're in the 20 to 30 range for the strong one.
Okay. Yeah, I'd have to do something if I wanted to actually get those. Oh, here's another one. No, wait a minute, this is the same one. Never mind.
Yeah,
Get used to the way this thing scrolls. You have to keep. It's easy to accidentally do the wrong thing.
right.
50. Could just type it in. There we go. Oh, I can see it.
Yep.
I'm amazed. It's there. I can actually hear it.
Now, according to my notes, at least on the 888 I tested, the Abies T knocks that down with a 50 ohm source by 6.8 dB.
Yeah. Oh, okay. It's less than one
It's about
scale
it,
unit here.
but
10 dB per division vertical.
but then again, it all probably depends on what the actual source load impedance is of
I'm
what.
sure it's getting knocked way down by Paul's filter. Paul's filter is still in line here.
Oh, that would be 20 dB.
Yeah, yeah.
Kelvin.
And
Yeah.
ordinarily, if the signal's still above if the noise floor, if the noise coming in is still above the receiver, I don't care how much attenuation there is, fine. You should do that. You should knock it all the way down if you can.
Right. So in northern Utah, we actually have three signal paths going into the RX-888. But one of the things that exists there is a box that does nothing but for the Kiwis. It combines the Omni HF antenna with an Omni E-field whip, and kind of multiplexes them at about 350 kilohertz. There's sort of
Uh-huh.
a point where it goes from one antenna to the other.
Like a diplexer.
Right, exactly. That's the word I couldn't think of. And that is what we get for the low end on the 888 there.
Mm-hmm.
There's also an additional diplexer for 6 meters, but that's only the 888. The Kiwis don't see it.
Mm-hmm. Just to minimize the number of 888s you have. That's what you need.
We have exactly one that is running.
Yeah.
But
Wow, WWDB comes through.
but the idea would be wouldn't be too terribly hard to build something that would scrape off that would low pass the AM broadcast band, but let's see, you'd probably want diplex around Paul's filter, so the stuff below AM broadcast band.
Yeah, yeah. Don't run it through the filter, but sum it in below.
But then again, raising it by 20 dB, I don't know how strong WWVB is where you are. I mean, here it's like a couple of millivolts a meter.
I figured it would be. I mean, you're a lot closer.
Yeah,
It's ground wave. I
in
don't
the
know what this is.
in the 80s. Well, that's is it exactly?
Exactly 70. It could be intermod. I do see intermod products at AM broadcast stations.
Well, I mean, I don't see any modulation though.
No, you're right. Okay, good point.
Is it now? Is there a way? I mean, is there a way that that thing shows you what frequency your cursor's on? I don't think that's.
Yeah, it's well, I mean, I have a cursor. I
I
mean, I
know
can zoom in and
the thing you're moving around on the screen
yeah,
cursor.
that's this frequency. The red line is this frequency. I
Well,
don't
yeah,
have something actually reading the peak. No, I don't have that. That's a
okay.
good idea to add.
Well, yeah. I mean, the Kiwi used to have it like more than once. It's like I just wanted to figure out what the damn frequency was, and I had to change the step size and fart around until it lined up
Right.
with the red
If
line.
at one time you could hit that activate cursor button and you could create a second a
Yeah,
blue
it works.
line. And there should be a horizontal hash at the amplitude.
Yes,
Yeah.
See?
but
Well,
but
I'm zoomed in as
that's
far as I can go here.
that is but that 70 kilohertz signal isn't exactly 70 kilohertz. It is a little bit off.
Right.
It is, yeah, slightly off. Am I going the right direction here? I'm trying to climb that peak.
Peak.
Oh, wait a minute. That's the receiver. Why did it? Oh, that doesn't move the cursor. That still moves the receiver, even when the cursor is active. Okay. There we go. 69.944.
No, that's your tuning frequency. The cursor's above that.
I'm
70.004.
sorry. Okay. All right. All right.
It's
You're
what
right.
4 hertz. I'm 40 hertz. It's 70 at 004.
Yeah, I didn't do that part. It used to be down
Cursor
at the bottom.
70.004. So
Yeah, I have to. I would prefer it in. I would actually prefer it in. Well, it should be in the same damn units as the main frequency.
yeah.
I mean, at HF, it should all be in kilohertz, so you don't have to sit there and count the thing that just
Yeah.
right at the decimal point.
Actually, my pet peeve with some of the JavaScript here is they use variable formats for some of these numerical fields, like this one. If it ever drops below 100 dBm, or around 100 dBm, it starts wiggling sideways, which is kind of distracting.
Oh,
You just have to put in a field width in the printf statement.
right.
Simple stuff.
Yeah, but JavaScript doesn't have a full-on printf like we're used to in C.
Well, it has enough of it. It has field width, certainly, right?
I think so.
I think last time I did that, I had to jump through hoops. I had to write something that figured out counted the characters and then padded them. But then again, it's assuming that also assumes that you don't have a font that I don't know. Is that a true type font or is that a
It's true type, but it's not fixed width because look at the I in Ben.
okay? Oh, of course. So that wouldn't even help you.
Mhm.
It would help.
Oh,
It wouldn't help you.
Loran. I'm seeing Loran. It must be Loran.
Yes, it is.
Yeah.
It is.
Is that going to be real, or is it just experimental?
I've tried to do research on what they're doing and been unsuccessful. I'll bring up the Kiwi and see if
How wide is it supposed to be, by the way?
Eloran. I'm not
Around
sure.
100 kilohertz. How wide
20
is it?
kilohertz wide
20? Thank you.
from 90 to 110.
90 to 110. Okay, so I can zoom in a
It's a
little bit
lot
here.
better
Maybe.
behaved than the original Loran was, where they had transmitters that were SCR based, thyristor based transmitters.
Yeah. I mean, this is too narrow. A little bit. Still trying to work out a good set of
See, I'm bringing up the Loran plug-in on the Kiwi in northern Utah to see.
Yeah, I've had mine successfully decode one or two chains. I mean, it wasn't like the old days, when it were easy, but it's
There's
still something.
two transmitters being detected in northern Utah right now.
Okay.
Right, there's just the one.
Yeah.
That even,
Yeah. That's Loran.
although it does sound different from the original Loran. Now, what
Yeah.
I haven't really looked into is how data is sent on the current version of Loran to eLoran.
Yeah,
Apparently,
the flipping the phase of pulses or turning one pulse on and off or something like that.
I don't know.
Probably phase. That's a little more
I
more
think they only
education.
mess with the one with one pulse. I think, but I'm not sure. I need to look into it.
Yeah. Of course, this spectrum analyzer is the wrong tool to look for pulse signals.
Right.
Should be doing autocorrelations. Another little gizmo to add. Autocorrelations would show up really nicely.
Yeah, the plug-in on the Kiwi has sort of something like that.
Yeah, it's how you identify the pulse repetition rate.
Well, you have to know it on the Kiwi, but we do.
Yeah.
I don't think the Eastern chains have been active on Loran for a while.
No.
No, it hasn't.
Yeah,
And it's not a chain. It's only one transmitter on the East Coast
was
down
it?
New Jersey.
Okay. They have. I have seen what looked like three transmitters active here before.
That's correct.
I only
West
see.
Coast has had up to 3.
Right.
One Loran transmitter is kind of like one hand clapping. It doesn't do much good, does it?
Right. I guess you can. I guess
Well, if you're doing timing off of it, it's okay because
Yeah.
it's got absolute timing.
If you know where you are.
If
Yeah.
if you know where you are and you do know where it is.
Yeah.
And that it's primarily been being tested for timing backup.
Yeah. It could also, I mean, a single station will also be good for just RF coverage testing.
and they have two. I guess with two stations, you can get position with some ambiguity, right?
Two stations,
Yeah, it gives you a hyperbola.
position along the line, I think. Yeah. Position along a hyperbola.
Well, yeah, I think you have ambiguity, but
Yeah. Three would give you two intersecting hyperbola, hopefully
right,
intersecting one point, I think.
right.
Occasionally seen stuff here. Over the weekend, I did see a whisper signal here, but I wasn't decoding whisper at the time. I've seen very little else.
You've never decoded my whisper, I don't think. But let me kick it on here. Let me kick on a CW carrier and see if you can.
Yeah, I'm not running Whisper Decoder right now. I mean, Rob has been so busy redoing Whisper Demon, I haven't kept up with him and reinstalling it.
Okay, let me bring up 200 watts of CW on for 630. Let's see.
All right, see if we can get through all my filters.
Yeah, I might be able to. There's a guy in town who lives across town, and I get into him when he has nothing connected to his. He has one of those Web 888s that he does decode, and with the coax switched away from his antenna, he decodes me. But that probably tells more about how good his coax isn't as far as the shielding goes. Let's see.
Well, this is remarkable. An entire band with not a single. Oh, there you are. Is that you?
Probably.
Turn it off. Turn it unkey.
Okay. Unkey. There we go.
That's you. All right. I am seeing you.
So, okay. Well,
I see. Well, I will put it back and I'll give you your signal edge ratio.
let's see. Hang on. Let's see.
Actually, I need to zoom all the way in if I'm going to do this right.
Here we go.
I'm going to zoom all the way in to 1 hertz per. Make sure I still have it. There you are.
Yeah, I'm running about 2.7 amps of antenna current,
Okay.
which is
Well, how much power is the transmitter putting out? I know it's not getting into the air, but
let's see here. It's a Class D transmitter. Let me run the numbers here. 4 plus. If I have my calculator too close to my loading coil, it doesn't work.
okay, let's see. The noise here is minus 134 dBmJ. Your signal is at minus 120. However, it's actually No, it's the right size.
Probably about
120.
175 watts TPO.
Okay, so I'm seeing you with about a 13, 14 dB signal edge ratio in 1 hertz
Oh, okay.
and a 1 hertz bandwidth. That's not a
Yeah, I
strong
mean,
signal.
if you're running whisper decoding, you'd have no trouble getting
I
me.
would probably be able to decode that, yes.
Yeah. Okay.
But yeah, I remember I'm using the bin is 1 hertz wide. The N0 estimate comes from the rectangular bin, so this should be still should be an accurate number. 130 minus 134. This number should be accurate because it's coherent, as long as it's in the bin.
I calculate my ERP is probably at this power level is probably somewhere between a quarter and half a watt.
You're well under your limit. What's it, 5 watts?
Yeah.
Probably hard for any hand to hit 5 watts on that band.
Few of them that do. On 2200 meters, it's a bitch.
Oh yeah, I don't think I've ever heard anything down there.
Yeah, I haven't heard anything this season. I've had a few QSOs down there, but longest one is a guy in Indiana, but it took like 2 hours before the band went up good enough that he could hear me. I could hear him, but he lived in he lives on a farm and had pretty long damn antenna.
Yeah,
Or I live on a city lot.
I guess winter is the right time to play in that band, isn't it? It's probably just too noisy in the summer.
Signals are better in the summer, but you wouldn't know it.
Mm-hmm.
I mean,
well, I haven't seen any lightning so far in my spectral display, like I see in the summertime. Lightning propagating the ionosphere. It's actually a very interesting ionospheric probe. Tells you, where the bands are open to that particular spot, wherever the thunderstorm is. I never know where it is. I know the Indians have a network of stations because thunderstorms are very destructive in rural India, and they have a network of stations on HF that basically just monitor and locate lightning.
HF?
I think so.
What somebody on this group was involved with that, as I recall.
Yeah, that's right. That's right.
Yeah.
It wasn't you, was it, Dave? You still there? Still listening? Oh, Dave McGaw, I mean. I remember somebody here mentioning that. Or maybe it was ARDC, because I think ARDC.
Oh, right, it would have been
Jonathan.
Who was it?
Jonathan.
Oh, it was Jonathan.
Yeah.
Jonathan, I think it was somebody in this group.
I have one of those Blitzer tongue receivers here at my shack, but it's tied to my I have an LF Engineering E-field whip that I bought when I was a teenager in the mid 80s.
Uh-huh.
And it's on my roof now. I have a metal roof, which allows me to, if I decouple the coax, shields me from many of the sins of living in an urban area. But but I have that connected to the Blitzer tongue. In the Blitzer tongue, I added some switch capacitor filters in it, so that it only sees things below about 24 kilohertz. Because otherwise, Jim Creek and whatnot just
go
to just blow it out of the water. So I have the knee, so it rolls them off.
Yeah, I'm sure modified sound cards are a much more practical way to get that stuff.
Right, but
and stuff designed for radio, real radio.
Right, but with that sort of kludgy arrangement, it mops the floor of most of the Blitzer tongue stations, which I'm guessing. Well, I tried using the supplied Blitzer tongue E-field whip, but it was deaf as a freaking post.
Mm-hmm.
And I imagine between that and not decoupling their feed lines, on the E-field antenna, probably is one of the reasons why most of the Blitzer tongue stations are pretty deaf, only hearing stuff near them.
That's Mexico.
540.
540, yeah.
Yeah.
Yeah, there's someone every 10 kilohertz step here. Let me go up one. Every single 10 kilohertz step, there's a carrier. It may not be anything I can hear on it, and these guys are so ridiculously broad too. Like here, I mean, What do they have? It really requires going out to 10 kilohertz on each side, or almost 10 kilohertz.
Well, they don't. They go to 5 kilohertz mostly nowadays.
No, they go to 10. I mean, that's what they use a total of 20 now.
Uh,
Even though they don't need it, it's all
I mean,
voice.
the one that's in the center of your screen is brick walled at plus minus 5. It's probably a talk station.
Yeah. Yeah, they
No,
have different widths, but
a lot of AM stations do have a 10 kilohertz bandwidth
yeah. But
modulation
what did
bandwidth.
they need it for? I mean, look at this guy. Okay. It's 640.
Not only that, but a lot of them. Well, I don't know if they do anymore, but a lot of them would actually peak the audio, have an upward uh, preemphasis in the audio to compensate for the roll off in the old LC type IF filters. Nowadays,
Okay.
everything is digital or uses ceramic.
Yeah.
Less of
I
it.
mean, the bandwidth here is look at that. It must have just changed program materials. There was pause and then they changed. So you don't always see this stuff, but you often do. It goes all the way out to 10 kilohertz and you listen to it in its speech. And all it does is clobber adjacent channels at nighttime when you want to do some DXing.
In looking at a lot of the local AM stations here, relatively few of them do run out to 10K or 9K or something.
Well, even our campus radio station is gone now, but it was had voice modulation, 10 kilohertz either side.
Hey, look at this guy. This is voice. It's all voice.
Yeah,
It's Mexican
it is.
station.
Yeah, they're authorized to do that now.
They're authorized to do it. I mean, he's not going all the way out. It's going out to about what?
You'll
8 or
also
so.
see other side bands because some of them are running digital.
Didn't they use
Rarely. Oh, there's only one that I see. You know which one it is.
1160 runs KSL digital?
Yeah, I think HD radio on AM is basically pointless.
Yes.
I mean, all it does is interfere with other stations at night, which is probably why a lot of them have turned it off.
There is, the only HD radio station around here is in fact KSL.
What was it? What's the frequency?
1160.
1160. There they are. And there they are, right there, and buried under this guy here. This I think is a local.
1170 probably.
I think is local San Diego. So
Yeah.
KSL's in there, but it's right there. It's
And what's also true too is I have a Grundig short receiver that will receive synchronous AM, and it'll receive either, but I don't think it'll receive double sideband synchronous. I think you only have a choice between upper and lower. And if you listen to KSL, you hear this wah 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 wah, because what they're doing is they're sending low rate data at a few hundred baud in band.
Oh, really? Let me take a look.
If you're receiving both side bands at once, it cancels out. But if you're only receiving one side band, the audio just has this growl under it.
Yeah, it must be orthogonal or something.
Yes.
Is that it? Maybe.
Yeah, if you were to listen to the audio, if you were to listen to the audio in synchronous on one sideband, you would hear this sort of growling noise under it.
Okay. What am I looking at here? I'm zoomed all the way in.
Well,
So each grid here is 100 hertz. So there's your low pass filter, and the audio starts at around 80 or so.
right.
What happened?
You tuned off.
Oh, what was that frequency again?
1160.
I need a lock button or something. Yeah, easy to do unintentional things.
And if you were listening to the audio, right now you'd hear wah 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 wah. You know, it's growling.
I've listened to them occasionally and it didn't seem anything unusual, but well, it might be hidden. I mean, if it's in a phase structure, it would be hidden in this. If it's in audio, I was looking for something subaudible, but it's not subaudible.
Well, they do
hear it. It's not subaudible. So
well, yeah. I have of course, I have a whacking strong signal here, and I can actually see the digital. There's digital that goes almost right down to DC, almost.
I know what I can do if it's in the phase. Fire up the Kiwi.
Now, of all the bizarre things, this is before they went to digital, I noticed they had a. So KSL used to have.
You are not part of the Jewish faith.
Sorry, go ahead.
Oh, so KSL many years ago, before they had digital, I would tune it in and I'd hear a really narrow FSK signal. They were shifting frequency of their carrier just by tens of hertz, sort of soft king at a low baud rate. And it so happens I knew the chief engineer there, WA7UUJ, and I asked him, and what it was is a pilot program for of all things, and you tell me if you can understand why the product failed. It was the idea was you put these low power, low rate receivers in consumer items. And if there was a recall, the thing could turn on a light to let you know that there was that the product was being recalled.
Say what?
Yeah, exactly.
It's pretty strange. Yeah.
Yes, it's like I asked. He said they paid us money for it. So of course we put it on. We got variants from the FCC to modulate frequency modulator carrier, and it's like, I mean, what kind of who would pay extra for that?
Yeah. All right. Well, here you are here's an IQ display. Now I don't know whether what I'm seeing on the
and we welcome that. We welcome that
I don't see any obvious phase modulation or quadrature modulation.
If you were to listen to it and switch between, both side bands and in your case a lower side band to avoid the splatter from 1170, you would definitely hear the audio. I mean,
Hanukkah, CHANUKAH. It's a massive list of all of our events. It's all over all of our social media platforms. It's at Jewish Utah across the social media spectrum. There's a lot going on. There's a lot of opportunities to partake and make the world a better place.
Wonderful. Thanks, Remy, and wonderful job last night. You weren't just at the podium
I can't really tell with both
really brought
us more closely. You say it's audible only in sideband mode, but not in envelope detector mode?
Correct.
Well, that says it has to be some sort of quadrature modulation.
Yes.
I don't see it.
Well, it's probably, yeah, I actually looked it up and I ran through the math and realized that, oh yes, actually the power stays constant. But yeah, there's like 3 or 4 data streams in HD radio. The big ones, I mean, most of the data is carried. I'm looking at the spectrum here, in maybe plus, from center distance from the carrier, maybe +5 to +15. No. +10 to +15. That's where most of the data is. But there's a fair amount of data in band that's down by, I don't know, 20 dB.
Okay, I thought I was sharing this, but I'm not. Okay.
It's yeah. I don't know if you could hear it on mine. If I were to share the screen and the audio, you'd very definitely hear it.
Oh, I'll go listen to it later. Let's see, PLO. Let me turn the PLO on. I want the PLO bandwidth to be really narrow, so any phase modulation will show up. Now it's just really, well, of course I tuned off a bit. That could explain it. It's 1170, right?
1160.
1160, excuse me. 1160?
Yep.
Oh, my waterfall gain must have changed. Okay. Where did they go? Let me normalize the waterfall here. Here we go.
And if I can, let me see if I can get it to lock, because of course I have a massive.
Oh, the PLL is locked here. You can see that. But what I see on the Q axis, I think it's just noise. Either that or very low level phase modulation. That's possible.
Let's see here.
I mean, it's just a noisy signal. I'm not local. And I'm seeing splatter from 1170 on the upper sideband. But try to cut that out. That's going to introduce a Q component.
So look at
the selective fading here.
So I have it. So I have it locked here, and I'm seeing I'm using the Kiwi's IQ display map.
Yeah,
Well,
I mean,
I
can you
use,
show your screen?
let's see. I'll show you what I'm seeing.
Yeah, you have a much cleaner view than me.
Let's see here. Oh, there it goes. Took me a minute for. Let's see. It's thinking. It's still thinking. Does it
Waiting for you.
carry?
There we go. Okay. I think you need to normalize your waterfall.
Oh, probably.
Auto scale. There you go. That's better.
So you can see, unless you have a suggestion for a different.
Oh, it's changed density to points in the IQ display.
Oh, let's see here.
Density to points. There you go.
I mean, I'm running. Let's see. Let's see if I run a. If I well, all I see is modulation. But if I go to a narrow bandwidth, then
well, what are you looking for? I mean, what frequency you're looking for?
well, whatever that modulation is. I mean, the modulation is the bit rate's a few hundred hertz.
Yeah.
Few hundred bits per second. Oops.
Well, yeah, it might be visible with a narrow filter like that. You lost your window.
There it is. Yeah.
Okay.
Let's see. I don't know that I can.
So let's see. The PLL is 5 hertz, so that should not get disturbed. But I didn't see anything close to the carrier anyway, so the carrier lock should be okay. And then the button below that, 2.4, 140, and 40, that's just the bandwidth for the IQ display itself. And you're looking at what bandwidth did you select?
Well, let's see. That's 40, and now I'm at 140, which
Yeah.
should.
I don't see any Q information.
Yeah. There's. Let's see here. If I make it. Yeah, that's
I don't see anything close to the carrier either. Now, if you do that, you just offset your. Sure, that's going to introduce quadrature stuff, right? Anytime it's asymmetric.
Yeah, I was just hoping for.
But it's not really there.
Well, yeah. I mean, it's you can look up the spec of if you look up the spec of HD radio and AM, you can read about the low rate carrier that's near.
Okay, I didn't know they had that. I mean, I only knew about the sidecar.
I don't. There used to be another station that ran HD radio here, and they didn't have that running.
Hmm.
So I mean, I don't even know what it carries exactly.
I know they have multiple modes, one of which is all digital. Nobody. Well, I don't know. Did somebody do that experimentally?
Yeah, I think in the 1700 kilohertz range they did that. Well, I remember they did that back in the 90s when they were demonstrating it. They had at NEB. They had I could hear it here. They had like a 5 or 10 kilowatt test transmitter running somewhere.
I see some hum in there. Good amount of it. Fundamentals. You can see it. Fundamentals removed, but you can see the harmonics.
Yeah, I mean,
anytime you have a microphone somewhere, it's going to pick up
it's a
some.
talk station. I don't know what their. Yeah. See what is it? Oh, I have no idea because I'm too narrow. But yeah, I don't think there's any other.
Now you're local, right? I mean, you're ground wave, right?
Yes, absolutely.
So that carrier should be absolutely clean. I'm wondering what I'm seeing on the sides of it. There shouldn't be any Doppler on it, or maybe there is. Maybe you do see small amounts of Doppler, even local AM reflections are moving around.
Either that or it's I don't know, incidental phase modulation. I have no idea. I've seen this transmitter in person.
Yeah, it's fairly modern, I assume.
It's a Nautel single. It's a single 50 kilowatt transmitter. It fits in a single wide rack, 7 foot
Huh.
wide rack.
Well, get the efficiency up. You don't need much cooling.
Yes, and it runs plus 125% modulation.
Hmm.
They used to run power side, um, years ago before digital, but that's not compatible. I don't remember what sideband they.
Oh, that might be what I'm seeing right here. You say it goes to 125 on peaks. That implies there's a very low frequency modulation, right? Bringing the average carrier power up on peaks. And that's probably what you're seeing right here.
Yeah, you're right. That would be
Is the very low frequency AMing of the carrier.
right. Yeah, they're probably doing. You're probably nowadays they would have to do like look ahead or something.
Well, yeah, you can actually do a lot of that without objectionable delay. But yeah, this seems to be correlated with the modulation peaks. So yeah, the modulation peaks are probably causing this low frequency stuff to be added.
Right, that would make perfect sense.
That makes perfect sense because I don't see this in other stations. I guess this is how you tell whether they're using additional positive peak modulation.
Yes. A friend of mine, he used to work for KSL back in the 70s, and he proposed they call it on the air the 67.5 horsepower voice of the West. But
6.7, huh?
yes. Well, there's that. Yeah.
Yeah.
I think you have to be under 20 to understand even what that's about, but
I just know it's a running gag. It's annoying a lot of teachers. I first learned about it on South Park of all places.
I don't get to watch South Park.
No, South Park's been great this season.
Yeah.
But I used to when I was a college student, I interned at Channel 67 in Baltimore. So it's long gone now. Spectrum is long gone.
Yeah, I think above above 65 was it? That was all educational at the time.
Well, basically everything on UHF was at one time. Hardly anybody else watching.
I was born in rural Indiana, and Fort Wayne only had UHF. They were too close to anything else to have any.
Yeah.
So
well, now those are premium frequencies.
Oh yeah. Well, I don't know that there. I'd be surprised if there's more than a handful of stations running VHF low band on digital these days.
Yeah, I don't know why is it so unpopular. The low band channels used to be prime, and now nobody wants channel 2, which is fine for us hams, but
well, I mean, first of all, nobody has. I mean, with 8VS with OFDM, you could probably get away with it, but with 8VSB, I wonder if the multipath that's almost you're guaranteed to have on low band is how.
True.
Now, the one thing I did see here last year, I was looking at my Kiwi clone. I have a Raspberry Kiwi that goes up to 60 some odd megahertz. And I was looking at it one day and noticed what looked like a digital television signal on channel 2 because I could see the bottom end. So I scanned on one of my TVs and there's a Bible beater with a test pattern that I detected, that locked onto it. The signal is crap, but breaking up, but I could tell that's what it was.
Yeah.
A month later, it was gone, and I couldn't find any reference to it in the FCC database, which is I don't know. Now I know other places in other markets there is VHF high that has digital, but
yeah, there's 2 of them here, 8 and 10 in San Diego.
Right. There was
both logical and physical, or VHF. Right. But
now, yeah, and what the only thing I know of that is uses VHF low is for channel 6 on ATSC 3.0.
Okay.
It includes an FM
yeah, channel 6 is special.
Yeah, and there's a number of stations who kind of got the FCC to allow them to put up a ATSC 3.0 digital carrier that had a good enough 87.7 or 7.5 megahertz carrier that people could receive it on their FM. receiver.
I guess with 3.0, because it's OFDM, you can turn carriers on and off, right? And then
Right.
if you want to clear 87, you could.
Yeah, there's apparently one of those running in the Los Angeles area.
Yeah, I think you're right.
Yeah,
I have an FM bandstop filter on my VHF UHF antenna. I can't even hear local stations. It's so good. It
yeah,
used to just blotto my receiver, which is why I put the filter in the first place. I need a separate antenna if I want to listen to FM.
right.
But I don't see any Channel 2 carriers on my Kiwi, on my RX 888, which is unusual. I mean, it's Southern California. On UHF, I see a carrier on every single TV channel, whether or not it's a local station I can actually receive. The carriers or the pilots are all there, but apparently not on low band VHF anymore. It's just the opposite of what it used to be.
I'm going to ask Google or using low band VHF.
I mean, KCBS, I think, is a logical channel 2 in Los Angeles, but they're transmitted somewhere else.
Let's see, 2021 is the only one I see here. It's a list. I think a few places back east had it. Let's see. Apparently, there's one in Grand Junction, Las Vegas. This is 2020. LA, K KWHY. San Bernardino on 5. According to this, I don't know. This list is 4 years old. I don't know if it's still accurate. So I mean, San Bernardino and LA might be detectable from where you are, kind of.
Yeah, I'm asking ChatGPT right now. No major full power stations currently broadcast digitally on RF channel 2. Legacy CBS, KCBS TV uses virtual channel 2, but its physical channel is 31.
Yeah, there's
There
according.
are occasionally low power or experimental assignments in FCC filings for channel 2.
Yeah, the Bible beater I saw must have been channel 2. Let's see here. Okay, here's a list of over-the-air. Where the hell is the list? If the web page is a list of over-the-air stations, where's the? So the web page is list of United States over-the-air television.
Okay, there is a low power digital TV station in Los Angeles on physical channel 2, KHIZ-LD, from Mount Wilson. Well, I should see Mount Wilson here. But it's virtual channel 39. If it's low power, I should still see its pilot on a narrowband receiver.
Right.
Of course, I got to make sure I got the right carrier offset, pilot offset. Pilot says for pilot is exactly where it's supposed to be, plus 309.44 kilohertz above the lower edge. Now let's go look.
What do you have that works there?
Well, my RX 888.
Oh.
54 dot what was that?
Oh, on
54
2.
dot
Yeah, on 2.
30944. That's it. Oh, I think I see something very weak. Nah, it's probably just a spur. I see a couple of discrete lines, but they're so weak that they're not an obvious pilot. Oh, wait a minute. Where am I going? I didn't type it fully in. 309.
54.309 something something.
Oh, wait a minute. I went to kilohertz, not megahertz. Get rid of the decimal point there. All right. That's better.
I don't think ATSC3 has a pilot carrier, does it?
Oh, good point. Is it ATSP? No, wait a minute. No, ChatGPT claims it's
It's probably
a
not
standard ATSC.
right.
Oh, it says KHIZ is LD is not doing anything exotic.
Okay. I mean, it's probably. I mean, most. I mean, there's sort of a. I was reading something where they were talking about a bit of pushback against nobody really wanting to spend the money for ATSC3, and I don't know how true that is. 54.31, I guess, is 54.309.440.559.
Telling me my loop won't operate at 54 megahertz. Well, it may be true. It's saying it's electrically tiny at 54 megahertz. What are they talking about? What do you mean electrically tiny? It's electrically huge at 54 megahertz compared to LFVHF where it's designed.
Yeah.
I don't understand. It's also telling me there's a lot of noise. Well, I know that, but I'm not seeing.
Mm.
I think it's making up stuff for me now. You always got to take what it says with a grain of salt here.
Have to temporarily connect your 888 to a different antenna.
Yeah, I think you're right. I do see a carrier just above it, but it's probably just a spur.
Are you using your loop to pick up the
Yeah,
California?
I'm trying to a W6 LVP. I don't know what the response of its preamp is, or if oh wait a minute, Paul's anti-aliasing filter kicks in where?
Oh, 30 or 60 megahertz. I mean, it's
Yeah,
claiming it to be down a ways, but it won't. It's not brick
it's
wall.
just over. I mean, we're not far. We're only 300 kilohertz above the top of the 6 meter band.
Yeah. If you have the 60 megahertz one, it
I
won't
do. Yeah,
not more than a dB or so.
yeah. I see a solid clean carrier at where is this? Just above where I was expecting, but what is that exact frequency? I used to memorize it.
09440.
30944 something something something.
Yeah, 309,440.6 for all practical
Well,
purposes.
that takes me down to a hertz. So let's see. 440 takes me to a hertz. That should be good enough.
Yeah.
Oh, there it is. That is it. I'd have in 54309.440, and it goes right on top of that spectral line. So that must be it. Right on top of it with a 1 hertz bin.
Wow, Shannon was right.
I got to tell ChatGPT it was blowing smoke. Let's see, it's minus 120 versus a noise floor of minus about 150. So I'm seeing about 30 dB out of the noise in 1 hertz. That's, 1 hertz. So C0 N0 of 30 dB.
Noticing my network drive disappeared from this computer, and it happens so occasionally, but it's so occasional I never can remember how it is that I bring it back. Probably needs I probably need to reboot this PC.
Oh, I'm not actually seeing the noise floor of the modulation. Let's see if I back out. What will this do? It should fall off at the bottom edge of the channel. Because yeah, I mean, you can get in and forget that what you're seeing is actually modulation. It looks like noise.
Right. Looking to see if it. You
I'm
see
looking to see if it falls off, it tapers off at the low end.
at
But
54.
I'm doing this though at let's see, a wider resolution band, 400 hertz. No, it doesn't look like it tapers off. I see the carrier spike, and that's about it.
Hmm.
Actually, I should zoom in and look at the floor with a narrower bandwidth. That might be more meaningful. But I can see that carrier spike. That's all I was really looking for.
Yeah.
'Cause around here, you see pilot spikes in basically every channel
Oh yeah.
because it doesn't take much to really be able to see the pilot. You're never going to decode it, but you can tell it's there. Yeah, it's actually fractions of a hertz, but KNIQ web interface only lets me go down to 1 hertz, I think. Or can I type additional? Well, I can type additional decimal places. 440 something something. Of course, at this resolution, it won't matter. If I put a PLL on it, I'll see the phase rotate. I learned though not to count on these as stable references. I mean, some of them are GPS locked, some of them are just off
Oh yeah.
by several hertz.
Yeah. Yeah. Glenn was noticing that he was looking at the Denver station.
Yeah.
Some of them appeared to be rubidium or GPS locked, and yeah. Of course, here in the probably less where you are, but around here, a good portion of the state you'd be looking at translators, which would be free running. The local NPR affiliate here uses one of the subchannels on one of the PBS, not the PBS station, but one of the university TV stations to convey their channels around the state, audio program around the state. So oddly enough, if you live in a rural area, you get stereo audio, but if you live in Salt Lake, you don't. Yeah, I think they dropped the stereo because they're running maximum bandwidth on their digital on their DAB, and they were the stereo sidebands were colliding with degrading the digital. I know the chief engineer of that station. That's why he said. Originally, they were running second audio carrier SCA there.
SCAs, yeah.
But I don't think there's any SCAs on the air in the Salt Lake area at all anymore. When the last two holdouts were, there's a Vietnamese or one on the NPR affiliate, and the BYU station had a audio for the blind service on it.
I guess nobody will ever bother using the SCA decoder I put in KNIQ radio. I never really tested it either. It was, I think I got RDS data out of it, but I didn't modulate it.
Uh,
But
SD,
yeah, so many stations have gone HD radio, they might as well just put their data there.
yeah, yeah, they I have a couple HD radios around here, but one in my vehicle isn't, oddly enough. It has satellite radio, but not HD radio. So I have satellite radio. You can get that for $7 a month if you browbeat them.
Yeah, but you'll never get rid of it.
Yeah,
You ever try to cancel them? Oh man, I went through that. You wouldn't believe how tenacious they are.
I could believe it.
Worse than the stories you hear about disconnecting cable. Like the one the SNL skit was done about years ago. That was great. Poor
Yeah,
guy calls up Spectrum Cable, says he wants to disconnect the service. And this, cheery attendant, um, guy says, yes. And what's the reason for the disconnection? And he says, well, my girlfriend and I broke up. I'm moving out. And he says, can I please have the reason for the breakup? It goes downhill from there.
my
Before
younger,
you know it, the end of the skit, a guy has shown up ready to install phone service that he never even asked for.
yeah, my younger brother, for a time way back when, worked for AOL in retention, and of course AOL was known for being tenacious too when people wanted to cancel, and that probably ranks up there at the top of the worst job he's said he's ever had.
Huh.
People wanting to just a damn cancel, and he was on orders not to let people cancel,
Yeah. Oh God.
but not let them
I
cancel.
am so thankful I never had to do a public facing job in my life, at least in my career.
I
I'm
never
just like uniquely ill suited for it. I don't have the patience I would need.
I never have either. So yeah, where I used to work occasionally, something would happen in the news, and they would send the TV stations would come out, and we draw straws on who got to who got to be on TV, and it was the loser who got to be on TV.
Now, ChatGPT is getting really pedantic here, trying to go through these C over N zero calculations. And come on, I know all this stuff. It doesn't understand me.
Anyway, it's 10. I need to go.
Yeah, all right. It's been fun.
All right, see you
Take
everybody.
care. See you guys. Good night.